Emerging Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies and the complexity it poses could disrupt society broadly and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring four main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions and others may be used through the workshop activities. This will be an exciting symposium and we hope you're able to join us for the whole event. Welcome to EDTAS. Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies and the complexity it poses could disrupt society broadly and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring four main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions and others may be used through the workshop activities. This will be an exciting symposium and we hope you're able to join us for the whole event. Welcome to EDTAS. to the Emerging Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies and the complexity it poses could disrupt society broadly and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring four main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions and others may be used through the workshop activities. This will be an exciting symposium and we hope you're able to join us for the whole event. Welcome to EDTAS. Emerging Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum,
they didn't include a testing and experimentation element as a matter of course. So we particularly focused, I guess, here in the assess phase where force exploration will experiment with defence scenarios and look at future plausible worlds to determine the future shape and structure and needs for defence. In addition to running continuously, this force design process differs from the former arrangements because it ensures that Defence employs a strong strategic centre-led process to deliver an integrated and joint force, eventually by design. It provides a transparent assessment and prioritisation process too to try and build trust with the central agencies and with government by ensuring that future investment decisions are evidence-based and aligned to strategic intent. In the centre of the diagram is where we get our interests and missions from government that we then build the rest of the design around. But I'd like to particularly highlight the critical role that industry and academia play in the force design process. EDTAS represents an important opportunity for us to develop better engagement with industry and academia. The time horizon of the symposium will support our focus on the assess and understand components of this force design. But we need to remain connected throughout, and in particular when we take proposals to government for decision, to ensure that we're agile and looking at any rapidly developing technology or geopolitical threats and the strategic circumstances at the time of making the decision. To achieve a joint force by design that meets government direction requires clear leadership from the strategic centre in the diagram. So we have a top-down design, but it needs to be supported by bottom-up innovation. And we're developing structures and process to make sure that we take this into account as this diagram shows. So within the force design process, we've structured steps to utilise industry knowledge and innovation. And a key takeaway from this is that we're aiming to be open and transparent about the opportunities for industry and to engage with the elements of our whole of nation's capacity for innovation. So as you're looking at the right-hand side of the slide. This has been done in the past, of course, but the focus for us now is to make sure this is routine and effective and doesn't jump to solutions too early, and particularly not to jump to solutions that are focused on a particular service or operational environment. Defence Industry Policy Division and the newly established Innovation Hub in the centre of the diagram assist in establishing industry innovation engagement plans and processes. As part of the force design process, we've analysed innovation focus areas and we recommended the first round of innovation priorities for the Innovation Hub. These were taken to the Defence Investment Committee and agreed by the Minister for Defence Industry in September of 2016. So determining innovation priorities is now a key outcome of our annual planning process, business as usual. Now, overcoming the constraints of classification and releasability of data and the subjects you're talking about are key to enabling that collaborative environment for early strategy concepts and design of this force. And I don't underestimate the challenge in doing that because you rapidly get into discussion of quite sensitive technologies or information. They're not trivial challenges and the process will take time to mature, but we're very confident that with the structures that have been put in place, we'll do that through incremental development. So we're aiming to take the forces that were previously designed for the air, land and sea environments and ensure that in future we're building them to be a joint capability from the very outset, as we're doing with HMAS Canberra in the top left of the diagram. Capabilities that Defence acquires can last many decades, and in this time, society and technology can change drastically. This symposium will assist our ability to design a force that should be able to be more effective out through that period. Disruption to the ability to effectively employ a joint force may emerge from a range of already identifiable trends, such as demography or climate change, and through changes in technology. So therefore, this newly established force design timeframe not only looks at what the acquisition decisions that need to be made in a particular year, but also trying to incorporate that forecast out to 20 years and more. It's inherently difficult to look that far out into the future. That's a given. But this is just one of the reasons why we're trying to engage broadly across industry and academia to learn more about what we don't know. Rumsfeldian knowns and unknowns are an underpinning reason for our keen interest and support of EDTAS. Changes in technology in particular probably have fewer known knowns, and they pose, therefore, a potentially greater risk of disruption. EDTAS allows Defence to explore a technology theme in partnership with industry and academia. The domain, defined by advances in information, data and technology, continues to gain momentum. It's shaping and shifting the way we live and the way we operate. In the next 15 to 30 years, new and emerging technologies, such as the Internet of Things, big data, artificial intelligence, machine learning, robotics, automation and virtual reality are likely to have many transformational impacts on the way we live and potentially on the way that a joint force effectively operates together in the future. Rapid change that results in disruption presents both an opportunity and a threat, and it's in this context that EDTAS is considering the future of information, knowledge and digital disruption as the theme. Your work will help Defence to understand this complex domain, and it might even identify near-term concepts which could be disruptive, and Defence needs to take account of them right now, either to shape the environmental outcomes that we want or to avoid undesirable outcomes. And it's tremendous to see the diversity of universities and industry representatives that we have here for the symposium. I really do look forward to the discussions, because having a look at the panel of experts that have been assembled for this, I recognise that I will be very quickly out of my depth as soon as they start speaking. But I really do look forward to that because that discussion, as I said, will be really informative for what we take forward in our work. And I particularly look forward to the big picture analysis report which will come out of the symposium. So it's with great pleasure that I welcome you all here and I guess formally open the EDTAS on Information, Knowledge and Digital Disruption. Thank you.
Thank you. Now I would like to welcome our first keynote speaker. And when we talk about digital disruption, you can have disruption in technology, but you can also have disruption in leadership and transformational leadership. And our first speaker is such a transformative leader. He has great experience and expertise on the whole innovation pipeline, from education, where he's been a lecturer, from doing the research, and he's got a very brilliant career as a computer scientist, working in robotics and in systems engineer, then pulling that through to technology that's out there in the world through spin-off companies, and he's run his own company. The person I'd like to introduce now is Dr. Alex Zelinsky. He was appointed as the Chief Defence Scientist in 2012, and so he is the person, I can't think of a better person placed to give us this first keynote address on digital disruption and what it might mean for the future. I ask you to join me in thanking Alex coming to the stage.
Thank you, Janice. It's a little bit too much information, too generous, I think, with your opening remarks. But let me acknowledge Brigadier John Mackenzie, Director General of the Force Design Analysis, Professor Hugh Bradlow, Chief Scientist of Telstra and President of the Academy of Technology and Engineering. And distinguished speakers, Defence colleagues, ladies and gentlemen. Good morning and welcome to the Emerging and Disruptive Technology Assessment Symposium. What a mouthful that one is. But Nigel from our group, they've come up with this term, but I think it's actually important where we're positioning these things, and it is an important aspect about technology assessment, and I'll come to that in a moment. But we're very much focused today on information, knowledge and digital disruption, and that's important, and I'll come to that while we're doing that. But I always begin by acknowledging the traditional owners, the Gadigal people of the Eora Nation, the traditional custodians of the land we meet, and I pay my respect to the elders past and present. The talk by Brigadier Mackenzie was excellent in the sense that it actually cast a scene where how you see defence is changing in the sense that force design is no longer an ad hoc function, which was traditionally driven by a white paper, which effectively would come out on a 10 to maybe sometimes 5-year, 10-year, 15-year basis. And then you would do a design which would then try to position Australia's defence forces for the future and effectively make the business case of why you would acquire certain platforms and certain technologies. the pace of technology and its development and its disruption has meant that we can't wait 10 years to buy something and then find out that it's actually potentially obsolete or has significant deficiencies. So the Australian Department of Defence has actually stood up a force design function which runs on a continuous basis, and it's informed by technology foresighting, and you saw that very distinctive square there, and in their business model that industry and academia will contribute to that. So that's a really important design. So that means forums like this are all part of shaping that. And one of the things that came out in the white paper was the redesign of the way we do business around innovation. So the white paper announced $195 billion worth of expenditure in the next 10, 15 years of programs. Within that, there's $1.6 billion for innovation, which is money that is at risk, but the department wants a ROI on that. We don't know which parts will be successful, which parts may be less successful. The point is, for the first time, the department is risking money. While all the other $195 billion of acquisition is really trying to acquire a platform. We know we want a new submarine, we may need a new fighter jet, we know what we're buying there. And there's risk associated with those acquisitions, but with the innovation program, we're actually putting risk out there in terms of developing technologies, creating technologies and developing them. So, and part of that is the Next Generation Technologies Fund. On your desks, or on your tables I should say, you've got this brochure. I'd like you to refer to this because this is a significant new announcement by government. It was announced on the 16th of March by Minister Pyne, and it talks about investments we're going to make in creating technologies in 9 areas. And the 9 areas are listed there, from cyberspace all the way through to trusted autonomous systems. And as part of that, we are investing $730 million over 10 years. But to shape those 9 technology areas, we're not going to be, doing what in an ad hoc way, making some plans today and then investing in 7 years or 8 years' time based on plans of today. We are going to be doing technology foresighting on the way to shape that. So this workshop is very important in terms, I should say, workshops, this symposium is around the technology assessment for those 9 areas. And the first 2 areas that we've picked off are in the areas of cyber technologies and the integrated intelligence, surveillance and reconnaissance. So this workshop is effectively trying to understand where technology is moving in those 2 disruptive areas, with the view to understand what are the drivers, what are the important things to worry about in terms of positioning ourselves to start making the investments. We've already started to make some investments just when the Minister announced the program. $10.5 million is going to be partnered up with Data 61 and cyber security. But that's for the first 3 years, so we can see where that program's going to go. But where does it need to go further beyond that? That's why we're here today and tomorrow, to talk about those things. So that's why this symposium is important. This won't be a one-off symposium. All those 9 areas will be addressed. Later this year, we'll be organising the next symposium on the theme of advanced manufacturing and materials. And in the first half of 2018, the symposium theme will be biotechnologies and enhanced human performance. So we'll be potentially looking at those areas, and that will then again start to shape the investments that we make in the Next Generation Technologies Fund program. So this is an important workshop, not just to come together to talk about where we're going, but actually to shape the future programs. So that's very important, and I think that's an important element to the program that Brigadier Mackenzie talked about. So this is the start of engagement. So it's not just defence people talking to ourselves, we're talking to eminent people. So, and it's really great to see. I look through the list of speakers, fantastic list of speakers, very well credentialed, as well as also business leaders. So we're here to explore the challenges, not just over the next 3 years, but take a longer view over the next 5 to 10, 15 years. Where are things moving? And I'd like to thank our partners for hosting this symposium, the University of Technology Sydney for co-hosting. Thank you. And I was just talking to your Vice-Chancellor, Tilla Brungs, the other day, and he's very, very keen on positioning his university to contribute to defence and national security. And also the Noetic Group for organising this event. Thank you. I saw Andrew Bolmax, their CEO, here earlier, but Andrew, welcome. Thank you very much for your support. And of course, inside Defence Science and Technology, Nigel McGinty and his team. Well done, Nigel. You've done a lot of work behind the scenes to get us here today. So, today's symposium centres around emerging and disruptive technologies. So what makes a technology disruptive? Well, I like to think of it in this way. It's when someone deploys a technology solution quicker than you can respond and deploy your own technical solution. In other words, you've been leapfrogged and you can't respond. If you can respond, well, it's not disruptive. And so I think that's like the way I like to think of it. And you might think about it in the commercial world. This probably means the difference between profit and loss, or even sometimes failure, going out of business. But for defence, the consequences might be much more significant, even catastrophic. So we like to talk about in defence science the idea of preventing or creating strategic surprise. So if you could create something like a hypersonic vehicle, we could move at Mach 8, that would defeat every known aerial defence system. That would be very disruptive, because all those technologies that are out there today cannot be deployed. Likewise, someone could do something legally to you to make your systems redundant. So that's you want to prevent those sort of surprises. So we have to think of technology, disruptive technologies, both from creating surprise and preventing surprise. And we've seen that sort of disruption in the commercial world. Think of the music industry. Think of print media, where it's going. And this is all due to rapid advances in digital technology. Even when I look at defence, there's disruptions going ahead which we haven't really fully come across. I was just looking at a statistic just recently that when you add up the number of platforms that are actually flying in the US Air Force, half of them now are unmanned, which is quite extraordinary. And at any time, there's an unmanned system flying 24/7 in the Middle East, conducting work on a far greater frequency than we would have expected elsewhere. To me, this is very disruptive to the opposition, when you can actually deploy forces on that cycle 24/7 continually. And also the idea of what it also means to the US Air Force when half of their platforms are now unmanned. So over the next 2 days, you'll be focusing on information, knowledge and digital disruption. So we've seen these areas move very quickly, and certainly even in the last 10 years, we've seen, since the beginning of this century, we've seen how technology shape and shift, and particularly on a daily basis. We are very much now interconnected with almost access to endless amounts of information, and sometimes that's supposed to make our lives better and make decision making easier, but it's actually a really interesting idea about when you've got all this big data. And there's this new concept which I sort of like, these ideas or concepts that you sum up an area, the 5 V's of big data: velocity, volume, variety, veracity and value. So people must have sat around for a while to think of that. But it's very good in the sense that when you think it through, it hits the things of quantity, quality and diversity. So this is the aspect of what you really want. Once you start becoming reliant on big data, you need it to be there. And certainly when we look back just under 20 years ago, Google and Amazon started their businesses. And at the time, I felt, well, okay, you're just going to search the internet and you might buy books online. But look where we are today with the sharing economy with Airbnb and Uber. They are not around less than even 5 years ago. They've come along and severely disrupting their sectors and the data it's generating. Of course, we had the social networking, Facebook, where everyone thought, well, that's a great platform. But since then, it's moved ahead with Instagram, Snapchat, Twitter. And of course, even with the music industry I talked about earlier, with Spotify, Netflix, these are all important platforms which we're now taking for granted. But you can see the velocity, I think, in recent years seems to have picked up now that we've got the base there. And I think that I really do believe in that quote from Mark Anderson when he wrote in the Wall Street Journal about, maybe it might have been 5 years ago now, when he said that software is eating the world. And very much the case. And what we're saying now is it's, well, you might say software is eating the world, but some people are saying it's platforms are eating the world, but they're based on software. But I'm still very much of the view it's all driven by software and these platforms. And we can see it now in the acquisition that we're going to make in our aircraft fighter, the Joint Strike Fighter, the F-35. I call it software with wings. It's 20 million lines of code are on that platform. It is much more dependent on software than any other part of the system. Yes, there's advanced stealth technologies, radars, all those other elements, but at the heart of it, it is a software platform, and very significant. So of course that means, there's lots of opportunities there, but there's also to continually upgrade that capability over the life of it, but there's also a potential for it to be disrupted. So the question is for us here is, and one of the things that keeps us awake in defence is, how does defence maintain its capability edge when the commercial world is now beginning to produce technologies that are equal, I would say maybe even arguably better than we have. So, and you can see that this is, just to give another example where we see this disruption from the commercial sector. Traditional domains such as space launches and satellite systems are now being successfully delivered by space industry. SpaceX is going leaps and bounds now it'll be the service platform to deliver to the space station and even deliver potential commercial flights. That kind of capability is now moving into the defence industries area. And how do we make sure that we can access that kind of technology for the good of the nation's national security and defence? So, but the other point is being constantly tethered to sources of information means that we have a growing need to identify possibilities of how that's made change to our future world. So I think one of the big areas that we can see is that in defence is the trend of urbanisation and the establishment of megacities. Now these megacities will have, obviously in a digital world, wired and wireless communications. So you can see there are obviously benefits in having highly integrated communication systems in megacities, I should say. But what happens in a conflict situation when the digital systems are not available? So we need to think about digital disruption from also the perspective of sudden non-availability. I think we all think about how we disrupt the new technologies, create new opportunities. But now that we're becoming so reliant on these systems, what happens when they become not available? In a large city, you can imagine if people can't get access to cash for several days or weeks, what that would cause in terms of social upheaval. So the future will consist of, we all know about digital mesh infrastructures, so enabled through hyperconnectivity and obviously innovative software solutions. So we have a very complex system with intertwined networks will present great opportunities for new businesses, but also challenges that could be hard to imagine. So we'll have no problems, I believe, in generating data or even moving it, but the key is how will we maximise the access and the use of information in the future? And as I said, how do you guarantee access and protect the data from being exploited or corrupted? These are open questions which I would hope this symposium should explore. Now, I'm sort of looking at the time here. I'm running a bit over time, so I'll just probably wrap up. I just want to tell you that in defence science and technology, we are very committed to investing in this area and certain areas. So, an example for integrating things. One of our long-term research projects is the Lasagna distributed software architecture. Great name, Lasagna, but I guess you get the sense it's layer upon layer. But what it is, it's about integrating systems of various separate systems, and we've been able to have a dynamically configurable networks for our Royal Australian Air Force bases and to move all the services together, be it emergency or protection services, vehicles, fuel management, base movements. Rather than try to deploy a system, we are trying to integrate all these systems into a system where they can be integrated, but in a way that is also accredited from a security point of view. We also work across, as I said, in cyber technologies. It's great to be working with Data 61. One of their projects there is the cross-domain desktop compositor where we're joining classified secret and top secret networks can be accessed through a single interface and in a secure way. Excellent work. This work is being trialled with Defence and government. We're hoping that these sort of technologies can be then transferred to industry and to be taken up in business more generally. One of the great areas that we're really excited about is software-defined systems, where software changes the behaviour of the system. So you can see that in software-defined radios. You can frequency hop, you can use everything in terms of the spectrum to be able to transmit and communicate information. But we see that software-defined systems moving into other areas such as electronic warfare. You could easily also have software-defined systems there. And likewise with radar, your radars are becoming software-defined. So ultimately, where we see these things converging, I can imagine that through one antenna or one interface, you can do communications, radar and electronic warfare, and all driven by software platforms. This is somewhere where we think Defence can really lead and make a huge difference. So this is one of our longer term areas that we'd like to pursue. And then let me move to the conclusions here and think about setting out the challenges for you in this symposium. Digital disruption in the national security and digital defence context is quite different from disruption in the commercial world. But all the same, Defence is not immune from these challenges and must adapt in order to maintain the leading edge. We must understand the social environment we'll be living in. So what will this mean for the way we work in Defence? So technology is obviously being enabled by gigabit personal communications, which are around the corner, and large data that is dispersed. So how can we have systems which are tethered by communication links with large data being generated, and what can we do with this? So I'd like to see through the syndicated sessions at the symposium, how can you explore the significant challenges, particularly for the research community? We're very interested in that. And the technology itself can be, as I said, disrupted by digital technology. We are now publicly able to say that Australia has an offensive cyber capability. So that is where you use cyber systems against other people's cyber systems to disrupt their cyber physical systems. In other words, their networks, their platforms, infrastructure. So please also think about how we should protect our marvellous new systems, which we are increasingly becoming dependent upon. So with that, I'd like to thank you for coming to the Emerging and Disruptive Technology Assessment Symposium. I hope that you make the most of the opportunities and discuss the issues and the challenges ahead in the next 2 days. I'm going to be here for the morning. I'm going to come back for the dinner tonight, and really do look forward to interacting with you and hearing from you about what you're discussing, and happy to discuss opportunities for greater collaboration and programs that we can build upon our assessment today. So thank you very much, and back to the chair.
Thank you, Alex. Now I'd like to introduce our first of our keynote speakers, and that's Dr. Hugh Bradlow. Dr. Bradlow, Professor Bradlow, is the President of the Australian Academy of Technology and Engineering, and he's the Chief Scientist of Telstra Corporation. He's globally recognised as a thought leader in telecommunications, and he was selected as the joint 2009 Australian Telecommunications Ambassador of the Year. He was named in the global telecom business as one of the 100 most influential telecommunications executives in the world, and by the Smart Company designated him as one of the 12 most influential people in ICT in Australia. Welcome to the stage, and we look forward to hearing what you have to tell us. Thank you, Hugh.
When someone gives you a brief to speak, the first thing you do is change the instructions, which is what I've done. So 10 years ago, I was asked to go to Puckapunyal and speak to an Army strategic planning exercise for 2035, and I thought, geez, that's impossible. I can't imagine what it's going to be like 25 years out. This morning, the instructions were to talk about 2040, and I thought, no, that's too soon because nothing really interesting will be finished by then. So I just changed it to 2050. But I'd like you to imagine that, and by the way, I'm not talking about defense. Nigel gave me strict instructions. I was just to talk about future stuff. So imagine yourself in 2050. Most of us will be gone, but for our kids' generation, they'll be at the peak of their working lives. And this is what the world will look like. And by the way, where I've put a tick on a bullet point, that's a sure thing. You can go to the bank and bet on that one. So let's look at transport. All cars will be electric because it's just going to be much cheaper to build them. My view is that no human being will be allowed to drive a car on a road, a public road. Most cars will be like Uber Pool. In fact, we'll have mobility as a service. We won't own our own cars. And if governments are sensible, they will make it impossibly expensive to own a car, just like owning an airplane is today. And what's more, there are likely to be flying cars around. People are already testing that in places like Singapore. In industry, the factories won't have people, the farms won't have people, but they won't have animals either because we'll be making meat with synthetic biology. Construction will be done without people. We'll be 3D printing houses and buildings and using robots. Cash will be gone. You can go to the bank on that one. Coal and gas-fired electricity will be gone. You can go to the bank on that one as well. But for those of you who are now sitting here feeling smug because you're in professions, don't feel so smug because there'll be a much lesser demand for professions because about half their work will be automated. Moving on, we're likely to have cured cancer by then with either a pill or an infusion. You can go to the bank that will have lots of virtual personal assistants, and I'll come back to those. And a bit more surprising, a robot soccer team will beat the human world champions. Crime will be significantly diminished. We'll have robocops in the street, and Dubai expects to have them this year. And all TV will be delivered by broadband. Well, that's kind of not a big surprise. So, why do I think all this is possible? I want to just talk about emerging technologies, but to do so, I need to just paint the picture of today's platforms. So, we have three sets of platforms today. The internet, going back 40 years, fixed and mobile broadband, going 20 and 10 years respectively, and cloud computing going back about 10 years. Why is that important? Not because of the disruptions that's already caused the economy, but because those platforms underpin a whole new range of emerging technologies that are coming out. So if we go on to those emerging technologies, I'm only going to speak about the first 5 or 6 of them, but it does include some weird and wonderful stuff like genetics, which I don't claim to understand, but which will have a major impact in that time period. And the big sleeper is 2D materials, graphene, silicene, all these sorts of things. They will have a massive impact that as soon as someone figures out how to manufacture graphene at scale, our world will change in ways we just can't predict. So let me give you a few sort of taste points of that world. The first thing is that we have to understand that the digital platforms are changing the way we're interacting with the real world because they're allowing us to measure and analyze that world and then to visualize and simulate it. And that's that visualization and simulation that's going to change all sorts of aspects of the world. There are some caveats. Alex has already mentioned security. We do need to do that. Security I don't regard, by the way, as rocket science, although it is. But the fact is that security is more about people and processes than it is about technology. So we do need to change the way we do things, but we will have the technology to make our world secure. And the other big thing is we've got to compute in a different way. Some people refer to it as high-performance computing. I refer to it, for reasons I'll explain in a moment, as computing at brain scale. Whoa. Oh, what did I do? The emerging technologies, the Internet of Things, I don't need to say too much about it other than to point out that the Internet of Things is really being enabled by sensor technology, and that sensor technology is kicked off at scale by these things. So the fact that mobile phones have created a whole new generation of MEMS sensors in the billions has enabled the cost and power of those sensors and the size of them to come down, and then people are starting to apply that sensor technology in all different sorts of areas, like biomeasurements, chemical measurements, physical measurements, particularly imaging. Imaging is a big thing across all spectra. You can add intelligence to sensors, you can make them communicate, which obviously you need to do to get the Internet of Things, and you can power them on either batteries or power scavenging for years at a time, and that's critical as well. So when you've got all those sensors, you create abundant data. And I've already mentioned that the platforms that we build on today, cloud computing has created abundant computing. Now, George Gilder will tell you that the way the world changes is based on defining scarcity and defining abundance. The defining abundance of the next 20 years is data plus compute. And when you've got data plus compute, you can actually change your analytical processes. So we're moving from a world that's today model-driven to data-driven. And that's quite a profound change. There were a few of us who in the 70s and 80s worked on speech recognition using things like hidden Markov models, etc. It was all model-based. You try to adjust the parameters of a model to emulate human speech. And as you can see from this curve, it wasn't particularly successful. Speech recognition at 50, 60, 70% is unusable. Along come Google in 2010, and they've got a massive corpus of speech data. They chuck it at a deep learning neural network, and hey presto, you can just see the curve climb. So that by 2013, 14, it's actually usable. By 2016, it's almost at human recognition levels. And probably this year we'll go past human recognition levels. In fact, Microsoft claimed that they'd exceeded human recognition levels last year. And then IBM debunked their claim and said it's still got some way to go, like less than 0.5% in recognition accuracy. So, but the point is that machines are recognizing speech because of that data-driven world, not because of the model-driven world. And we start applying that. I'll skip that. I think you all know you can talk to your house. It's been quite common now for a couple of years with Amazon Alexa. So the other big thing about this data-driven world is we can start doing simulations in a completely different way. And virtual reality is kind of a gimmick at the moment. It's still inadequate from a technology perspective. Interestingly enough, everyone expects, again, mobile phones to drive virtual reality, so that's why you see mobile phones coming out with 4K screens. When I get a phone like this, which has got a 4K screen, as I crank the resolution down to 720p, because I don't want to flatten my battery, but if I were to stick it in a headset, that's a different proposition. I need that resolution. And once you've got that virtual reality and you've got the technologies and the APIs to build up the software, you can start simulating a virtual world. And, you know, I give an example there of simulating the operation of a diesel engine. It's much better than actually going into the lab and doing that actual operation of the diesel engine and doing the measurements, because you can start visualizing things like airflow on top of the engine. In fact, in the 1980s, I suggested when I was a professor of electrical engineering that we should get rid of labs and engineering entirely and do everything by simulation. I didn't get a lot of support, but I will eventually be right. It's just a matter of time. The other big thing, of course, is augmented reality. And Alex referred to half the aircraft in the States, US Air Force being unmanned. Virtual reality is going to, augmented reality is going to really change the way we do things like remote service operations or remote military operations, because now you're actually mixing the realities of the physical and digital world. That's an example that Microsoft give with their HoloLens, where a woman is doing some plumbing in a flat and her father is instructing her using an iPad, and he can see exactly what she's seeing. And when he draws on the iPad saying, unscrew the U-bend, she sees that integrated into the U-bend. It's not an overlay like Pokemon Go. It's truly a merged reality. And so, companies like us are very interested in that, because we'll be able to stop truck rolls, or a lot of the truck rolls, by doing that. So that leaves, besides security, which I won't cover, that leaves the computing at brain scale. Now, if you'd asked me to give this presentation a month ago, I would have said we've already actually got to the point where we can compute at brain scale. Someone worked out that the human brain has a processing capacity of 37 petaflops, and last year the Chinese released this computer called the Taihu Lite, which actually has processing capacity of 93 petaflops. However, some recent UCLA research came out last month which said actually the human brain has a processing capacity of somewhere around 4 exaflops. It's quite interesting why they came out. It turns out our dendrites are actually part of the processing system. So the point is, though, we're starting to get close to the actual computing capacity of the brain. There's one huge difference, though. A brain uses about 20 watts of power, which is roughly a light bulb, and this Taihu laptop uses 15 megawatts. So you need your own power station pretty well to run the thing. So if we're going to scale up artificial intelligence, we need to be able to compute at brain scale, by which I mean we've got to get the petaflops per watt down to a human brain. And people are looking at roughly at the moment 5 different approaches. I'm sure there'll be more coming up. I won't go through all of them in detail, but there's some groups, the IEEE has this rebooting computing initiative where they're looking at how you can use specialized processes in classical computing. IBM have their synaptic computing initiative where they're trying to look at the way in which they can physically emulate the human brain and the neurons. Quantum computing is all the rage. It's led to a rejuvenation of physics. It's got billions of dollars are going into it, and I have no doubt over the next 10 to 20 years, people will come up with quantum computers which will perform yet to be seen calculations, so-called quantum supremacy. But there are people who are also looking at optical computing, and that has some interesting wrinkles as well. And then we get into DNA computing, where you could literally store the entire information of today's world in this room. So a lot of exciting stuff happening in the high-performance computing world. Just a quick comment on energy conversion. This whole debate about coal and everything, why do I say we'll have no coal in 2050? It's because it'll be far cheaper to produce 24-hour supply using renewables, far cheaper. You can already see by the end of the decade that dotted red line says even in Germany where they have no sun, it'll be cheaper to do solar plus a battery. So let me end up by giving a couple of thought experiments. That's kind of what I do with my life, is I sit and look at emerging technologies, study them, understand them, and then I go off and do thought experiments which say, if those technologies were generally available, were made mainstream, what would we do with them? So let me start off with virtual personal assistants. You can already get Band-Aid sensors that you put on your chest and are effectively a single lead ECG. They will continuously transmit your heart wave, not your heart rate, through your phone into a cloud data center, and it's just a matter of time before people apply AI algorithms to that cloud data center, those waves. And think about this on a scale of 7 billion people with all those heart waves going in it. And those AI algorithms will be looking for anomalies, which are the sort of thing that AI potentially at that scale can do quite well because there will be a lot of data. And when it spots an anomaly, it'll alert a human who will make a decision about an intervention or not. So one day we'll be sitting here and every now and then an ambulance will come in and cart one of the members of the audience off, and they'll be feeling perfectly fine. The other big change, I think, is in education. The educational institutions are the most resistance to change you can imagine, and so they don't want to even think about this possibility. But our education is going to change dramatically because we can start creating personalized education flows, effectively virtual personal tutors. And there are already companies like MindDojo who are doing what I'm showing in the slide. They take an individual course that a student's doing. It's done online, of course. They use what I've called the endogenous data. Those are things like assessments, the amount of time a student spends on a unit, etc. And they then adjust the flow of the course to meet the needs of an individual student. But there's the so-called exogenous data, which is much more powerful. For example, you might use a camera to do sentiment analysis on the student so that you can see this unit is boring to him, and then you speed it up. Or you might see that his heart rate's gone up and that he's really excited by it, and so you give him more of that type of thing and adjust the flow. So those virtual personal tutors will give us a completely different way of doing education. The world of policing, we're getting really close to pre-crime, for those of you who are old enough to have seen Minority Report. This is an example I took from Washington, D.C., where they have quite a lot of gun crime. So the Washington police take all the data that they can get hold of, the data from their surveillance cameras, the data from the microphones around the place, Twitter feeds, social network feeds, traffic information, weather information. They chuck it into a big data store, and they start running analytics on it, and they're able to then predict on a day-by-day basis where they should deploy their police, because when they see those hotspots, they start pushing more of their police forces into those particular areas. And as I mentioned before, we'll start seeing robocops, and surveillance will be just a fact of life. Transformed, why did I say you should not be allowed to drive a car? Well, this is what the world of the future will look like when we have fully automated autonomous vehicle systems. That's an intersection, there are no traffic lights, no one's stopping, and there are no accidents. So it has huge benefits in terms of the health system, in terms of capital that we invest into our transport system, and into convenience, because every journey becomes utterly predictable. You pull out your phone, or the phone automatically, based on your diary, it joins up your journey and comes and fetches you at exactly the right moment. Watch this guy. You do need to do a little bit of user education. I'm not saying it's going to be easy, but the human factors there will be a challenge. Farming, that's actually the world's biggest indoor farm in Newark, New Jersey. They've taken old warehouses in a really rundown area of Newark. It was so dangerous, they told me I couldn't walk 400 meters between buildings because I was likely to be mugged if I did. But they've got this new farm there which is producing green leaf vegetables on conveyor belts. You can see they stacked up 9 high. Everything's accelerated, so the growth is, the germination's accelerated, the growth is accelerated. There are no insects because it's an indoor clean environment. There are no herbicides, there are no pesticides, there are no chemicals whatsoever. It goes on a conveyor belt and comes out the other end, goes straight into a punnet, and it's on a supermarket shelf within an hour of actually being grown. So a huge change in the way we deliver food in this new world. However, let me end up by saying it will cause massive social disruption. And that is going to be the biggest challenge that I think we all need to face up to. So I've been encouraging governments that they should be proactive about recognizing the changes, because as Alex said, a disruptive technology is when you have to be proactive. You can't wait to respond or be reactive. And governments will have to do a lot in order to address the social issues. Just a simple example, I think mental health is the disease of the future. We'll cure cancer, but we'll have a massive problem with mental health. We need to ensure that people are adopting technology at the best possible rate, so we do need more collaboration between industry and research. And we do need to regulate to ensure that we're not overcome by vested interests, which is what's happening in the energy debate at the moment. And with that, I will conclude on time, more or less.
We do have time for 1 or 2 questions. Please.
Do you see this as being a universal model, or the islands of technology in a sea of chaos model? Because I can't actually see that model working particularly well in the Horn of Africa, for example. I could see it in New York, or Newark, or DC, or even Sydney. But do you see it as a universal?
Yes, I do. It's just a question of timing. If it doesn't work in the Horn of Africa, then we're going to see continuous mass migrations, which we're not going to be able to cope with. So it has to work universally. It will happen in the developed countries, no question about it, because the forces of technology will ensure that. But we have to ensure that it happens in the Horn of Africa or wherever.
Now I'd like to ask Nigel McGinty to the phone. He'll set the scene for what's happening in the next stage of our symposium. So I'd also like to ask you to join me in thanking the previous speakers.
Good morning, everybody, and thank you for coming to EDTAS. What we wanted to do in this session was really just talk about how we see this event unfolding over the next 2 days. So myself and JP Smith, who is just coming up to the stage now, will just go through this with you slowly. Now, I understand it's the green button that I need to press. I can only press one button, except it doesn't work. There you go. There we go. So EDTAS has been designed to be a campaign of activities for us. So this is just one step of our journey of exploring information, knowledge and digital disruption. It started a few months ago where we started to unpick this theme. We ran some internal workshops and a series of SMEs were interviewed over the last, I think, 2 months or thereabouts, and so that produced the insights paper, which I must apologise for only getting that out last Friday, but rest assured we've been sprinting on this event to get that far. But the insights paper is designed to go and just put some thought-provoking questions out there and things that we'd like to explore within the workshop elements of this event. The next stage is really about understanding the technology and where it's heading and what the opportunities might mean. So I've written it here as the focus technology scan, but that's what we're here today and tomorrow really exploring. And so what will come out of this will be the big picture report. A couple of years ago, DST released the Forward 2035 report, which is a general technology scan and implications of megatrends that were drivers for the Department of Defence. Well, we want to do an IKDD version of that, and so we've got a Tiger team ready to start to write that up after this event. So the other thing I wanted to talk about was what's the time frame that we're really interested in here, and you will see that this is a recurring theme through the event. And I wanted to step back in order to look forward. And some of these pictures were very similar to what Alex mentioned earlier. So we want to look forward 20 years. So let's look back 20 years, 1997, where Alta Vista was the search engine of choice. Netscape Navigator had just come out and we're still doing Windows 98. Mind you, if any defence people here would of course know that our computer systems were still using Windows 98. 2007, 10 years ago, the transformation was still happening. So Google started dominating. The iPhone had just come out. The way we interface with data, Web 2.0 applications were really starting to dominate post the dot-com bubble burst of 2002 or whenever that was be. To now, where we have data services certainly informing the way that we work, and Uber and Airbnb and Facebook and Alex went through a big long list of those that are today that are really defining what we do. And this reminds me of the CEO of Bank of America made a statement once that he doesn't see himself as a bank, he sees himself as a software company with a banking licence, and that is really the story. I hope Defence remains to see itself as a defence force, not as a software company with defence obligations. So what about looking forward 10 years to 2027? Who knows? That's actually not that far away, as Hugh referred to in his presentation, in 2037. So to think about that space, I've just got a slide here of some technologies that I think we could be considering. Certainly, there's at the strategic level, there's a lot of discussion around what will that future world look like. The World Economic Forum certainly has the fourth industrial revolution under their guise, and Klaus Schwab leads that push. There's also a few other books looking at industries in the future, but cyber, physical and digitisation of almost everything is essentially the theme that we need to be considering there. So MIT each year produces their top 10 breakthrough technologies, and I was actually just in a hotel room last week putting this together, thinking about it, and this year's version of the breakthrough technologies 2017 was in there. So I looked at them, and 5 of them, no, I can't count, 6 of them are all related to our theme here, and I think that's a telling story. So neural interfaces, and how do we interface with data, and how are we going to digest that information is a key theme, and we do have a couple of speakers looking at that later. Self-driving trucks is another theme that they see in the next 12 months to 5 years as taking over in the US. A lot of push there, so this will be well before the self-drive car is their theme. They've got a theme around paying with your face, so it's using biometrics to interface with information, interface with the virtual world. 360-degree cameras, so once again that's coming into interfacing with the analogue world and just being aware of our surroundings. Interesting, and we've had a couple of mentions of Internet of Things, or Internet of Everything is another phrase that's often used, but this one was new for me, and that's the botnet of things. So this really touches onto the security piece, where every connected device to the network, of course, is a potential threat and can do harm. And reinforcement learning, it was flagged again, and that's probably no surprise. So area that IEEE do a similar thing, and I won't really recount because there was a lot of similarity between them. But 5G, here comes 5G, is their big piece, and Hugh showed the video earlier of the cars interacting, and so one of the underpinning technologies of that is the millisecond capability that 5G brings, 1 gigabit per second to each and every one of us. Augmented reality, and their catchline there is forget the glasses, but it is certainly augmented and virtuality future, and fold up and roll up screen. So it's really just how we're interfacing with data. So I just pose that for consideration as you move forward. Certainly Chief Defence Scientist and Hugh Bradlow also offered some interesting concepts for us to consider, as will our speakers in the next session after morning tea. But what I wanted to talk about was, my bill didn't work properly here, but there you go. What I wanted to talk about was just some frameworks in terms of thinking around disruptive technologies, and this is worth considering when we go into the workshop elements. So the first one are the cones with the 4 Ps. So now is over to the left, and somewhere into the future, whether that's 10 years or 50 years, it doesn't really matter. It's over to the right. And basically they're saying whatever is possible, there's a huge area of what is possible, but what's plausible, those things that we'd actually can achieve. Free space travel is probably not possible. Getting to space might be possible, but it's probably not plausible. A small set again is what's probable, what's actually ethical and legal for us to do. And moving from that is the preferable vector, which is probably, or could well be, I shouldn't use Ps, could well be a different trajectory to what is probable. And all of that is worth considering in our workshops. The other diagram here is really the discussion around disruption, and adoption of all technologies tends to be around the S curve, where you have very early adopters, not much happens, you get rapid adoption space, and then it peters off, and you put every industry since day dot could map to that. But the real question is whether it is still continuing or whether it's laid off. So when I press the button enough times, you'll see an arrow come up there to really raising that question. The other way to consider around disruptive technologies, it's not about the technology, it's actually about all those other perspectives and the congruence of all those things coming together, which creates a disruption. So the social, the technical, the economic, the environment, the political, and our value set. And so we will consider that through our workshop elements during the day. There's my arrow that's just popped up of asking whether we're flattened in the IKDD space, or are we remaining on that high level? The other curve I want to pop up, which I've shamelessly stolen from Gartner, who uses this hype curve to consider technologies, is really worth considering. So the right axis, the vertical axis, is about expectation or visibility, and the x-axis is maturity. So for innovation technology, it starts over to the left of the trigger space. You get to a period of, they call it the peak of inflated expectation, but there's a lot of hype around the technology, and it will be our potential saviour, until we start to realise, well, what it can and can't do, and that comes down to the trough of disillusionment, and then disillusionment, and then ultimately through to the plateau of productivity as we adopt technology. Now, that's really worth considering, because some of these things that if we really project forward, we remain in the hype space. That's all fine, but we just need to be aware of those considerations. And I think that is all I want to talk about.
Good morning, folks. My name is JP Smith. I'm your lead facilitator during the workshop phase. And just before morning tea, I just thought it's worth just explaining the kind of the workshop phase of it, because it's an important part of the EDTAS process. So it's really, this is the approach part, and it's bringing together all these parts, because really we want this audience to be the key insight developers, because in the end, kind of it's your collective brains immersed in a series of different environments and scenarios, which we'll put you through over the course of the next couple of days, and that together will build the big picture IKDD report, as I think we're kind of we're badging it over in the couple of weeks after this event. So the approach is really built on a number of kind of methods. So the first is this environment, and apart from the fact that it's not a bad view out there, it's you all assembled in the type of groups that you are, and you'll note kind of very cleverly that obviously all the DST people aren't sitting together and all the UTS people aren't sitting together. In fact, you're all just purposefully dispersed, and that is to encourage insights and get your kind of minds thinking and bump into new people and all of that, just to kind of share ideas and get new perspectives. Clearly, we maximise the use of you all, so through both keynote speakers and also the session themes that you'll see in your program. So in the keynote speakers, we'll take the opportunity on one-on-one just to have a Q&A with those keynotes as we go along. With the sessions, they're designed to be short and sharp. It really is, just this kind of flood of ideas. So we'll have a bunch of session speakers. If you're a session speaker and you want to go longer than 10 minutes, you'll hear several annoying noises which will prompt you that your 10 minutes is up. You'll then you'll be part of the panel and you'll get a chance to kind of engage with everybody on the panel. But that is the second part. And then also, there's a virtual audience. So I'd like to say, first of all, good day out there to all the folks that are viewing me kind of through the streaming process. Hello, welcome. Also, UTS is doing a separate engagement, and they will come in tomorrow and give us some thoughts from a student body on this. So that's another approach that's being taken. So you can see there's a bunch of ways that we're going to generate ideas and insights just from using you all. And then last, there's actually the workshops themselves, and I'll step you through those just to kind of debunk the myth and calm you down, I suppose. It's very relaxed, everybody, so don't all run away. It is very relaxed and very informal and also a bit of fun. But all of that is designed to build and work towards insights and concepts that we can use in the report. So if you are viewing remotely, then you can engage with us through the hashtag EDTAS in capital letters. So please do that. We will monitor those and inject those into the various engagements as we go. And just with the workshops themselves, the logic with the workshops, we're going to build this through. So we'll take you through, firstly, some of what's possible, and I'll get you all in your tables to just think about the kind of what's possible out to 2040 in that information technology space, and we'll do a bit of work on that. And then after, and we'll do that kind of over and around lunch, and then in the afternoon, we'll actually start to insert that into a mega city, because that is really the future of kind of humanity. We will be urbanised and we will be in these hyper-connected mega cities. So we'll look at how those technologies sit in a mega city, and then we'll take that a bit further and we'll actually look at an individual. We'll try to get you all just to kind of think about your ideas, but then put them in an individual and just talk an individual through a day in the life in a mega city. So that will all be done in your tables. Then tomorrow, we'll take you through, okay, so what's the impacts of that? What's that mean from a capability perspective? How do we actually bring some of these technologies forward? What are the constraints? And take you through some scenarios in terms of, what happens if we go off the grid? What happens in a kind of, in different environments? And then lastly, we'll take you through and have a look at some of the social, the ethical considerations that actually may be some of the real blockers or perceived blockers in actually enabling some of these technologies to go forward. So that's the process. That's how we'll actually workshop in between the various session talks and everything to take you through the path, the journey. To help me, just lastly, if I could just get to stand up the facilitators. Andrew Balmax, Matthew Graham, Simon Cullen and myself will be the facilitators. Don't worry, we'll introduce ourselves and tell you where to go, and I'll be back to give you a little bit more guidance. And look, just lastly, if you have any questions over the course of the time, Andrew Crowe and James are the two coordinators, so they will keep everything on shape. And lastly, very importantly, where is Anita? Anita, if you have any venue issues, catering, anything like that, anything at all, go see Anita, she'll sort you out. Look, with that, thank you very much for your attention. I'm in the way of morning tea, so please, let's have a cup of tea, and if we can be back here, seated at 10:30, ready to go. Thank you very much.
My name's Lynn Booth. I'm the Chief of Joint and Operations Analysis Division in DST Group. So this session, as you've heard, is to set the scene for the workshop activities that follow, where everybody will be participating in the process of the ideas generation. But we have a group of eminent speakers here, 6 people, who will provide some ideas and context to sort of get those thoughts flowing in the next session. So each will speak for 10 minutes. I understand that will be strictly enforced. And then there will be a 30-minute question and answer session where we can interact with all of the panel members together. So no questions after each presentation, but we'll have that at the end. So our first speaker today is Professor Jill Slay. So Professor Slay is Director of the Australian Centre for Cyber Security at the University of New South Wales, Canberra at ADFA. Professor Slay is a member of the Order of Australia for service to the information technology industry through contributions in the areas of forensic computer science, security, protection of infrastructure and cyber terrorism. So please welcome Professor Jill Slay. Thank you.
Do I have... This is the clicker, is it? Where's the clicker? The green. Okay, cool. Just checking. Thank you. So I wanted to talk about cybersecurity and the Internet of Things. I'm actually going to draw on some of the issues that the previous 2 speakers talked about. I wanted to just clarify, as it were, the difficulties with the cybersecurity, and these have already been touched on, and the complexity caused by the Internet of Things with a couple of examples. I haven't got a particular defence slant on what I do, but you would envisage that because of the nature of my teaching and my research, it's the context of where I work now. I've been helped to understand about, as it were, the potential use of the Internet of Things by defence, more by my relationship with Northrop Grumman and being able to go to the US through tech fests and things like that to actually see what the defence contractors imagine the soldier and the platform of the future looks like. So essentially cybersecurity is diverse and it's got different focuses really, but it's got, we would like to suggest that when we're talking about cybersecurity, we're actually talking about at least 8 different factors, issues. I think that for those of us who've come from technical backgrounds like engineering, cybersecurity was once upon a time, or information security, or computer network security, was seen largely as technical issues. But, and this useful graphic, which comes from Bell Labs originally, and we've extended it, tries to talk in greater depth about the fact that cybersecurity is dependent on hardware and is dependent on software, but there's also implications of policy, an ecosystem, payloads, and people. So whenever we're talking about the Internet of Things and the security issues that relate to the Internet of Things, we're actually talking about many of these components as well. So as we look to the future, we have to be considering these issues as well as the troubling and challenging ones of actually the technical issues of the cybersecurity of the Internet of Things. So what's the problem? The problem is because we are seeing, so the Internet of Things is here with us now. We could say that it has emerged, but also it is emerging. So it's emerging in a context where more broadly and more generally we have concepts of targeted attack, and as we've heard, we can speak publicly about the offensive capacity, that Australia has offensive capacity it's in cybersecurity or cyber effects. So therefore, we're looking at this problem in a context where we have weaponisation of the internet, offensive cyber warfare, but as we drill deeper, lack of understanding of what cybersecurity is or might be, lack of a security culture. Even though the concept of security culture within organisations and enterprises has been around since about 1999, mentioned by OECD, we could also decide for ourselves that there isn't such a security culture in many enterprises. large numbers of SMEs, and such a large proportion of our industry is SMEs in Australia, who have little or no cyber protection. Poor management of the issue of cyber security, even though we see improvements in that. And very much in the critical infrastructure sector, poor communications between engineering and IT security and physical security, IT security and management. That's been the result of our own and other people's research. So this is the context in which the Internet of Things emerges. So as other people have said, we're basically dealing with people, processes and tools. We can draw on models of cybersecurity, the technical cybersecurity, like diagnostic frameworks to broaden our thinking. And so every time we see a device being connected to the internet, we can think in terms of a framework. You know, we're systems thinkers, right? We're trying to be systems thinkers, but as engineers, we very often chop the world up so as to be able to deal with the complexity of the problem. So when we're talking about small devices connected to the internet, regardless of the device, we can look at issues like access control, telecoms, software development, crypto, and many other factors. These frameworks are very common, and this is the model that comes from ISC squared. So does the Internet of Things add to complexity? I've been speaking at Internet of Things forums where I actually usually start my talk by saying, I'm the person who's going to come here and pour cold water on your enthusiasm. Because as we've been told, the Internet of Things roughly is about the development of sensor technology to give us really very, very accurate sensors. But in the development of these really accurate sensors, there are many other issues. Some of these facts are quite contentious. I've tried to find the latest definitions. Keep being told there is such a thing as Internet of Things standards. I can't find Internet of Things security standards, but I can find many vendors and different groups like the Cloud Security Alliance, the link between the cloud and the Internet of Things, the link between a security toolkit and the Internet of Things, secure platforms and the Internet of Things. But while we can come up with devices that exist now, devices for the future, some of the what we could have called scientific or technical fundamentals, I believe, are missing, just in the way, and I would try to draw this parallel when we consider the Internet of Things, particularly, let's call it the industrial Internet of Things. I think we're at a time where we're seeing some of the same developments that we saw with the critical infrastructure sector or the SCADA sector going back to the early 2000s. So we saw devices grow, we saw people with vendor-specific protocols, and then from 2001 onwards in particular, we've seen attacks on the critical infrastructure, sometimes the exploitation of protocols, but the exploitation of people, the exploitation of many other factors which give us the critical infrastructure sector. So just as I don't think we've fully dealt with the security, cybersecurity issues of the critical infrastructure sector, industrial control systems, SCADA, I think we are in a time when we're going to have the same issues with the Internet of Things, the Internet of everything. So the challenge we face, no consensus on how to secure Internet of Things devices, no comprehensive solutions as far as I can tell from my reading. We see large-scale acceleration of the use of Internet of Things sensors, and this is very exciting. There are wide-ranging communities who are highly excited by the sensors we might use, including the defence sector. So I'm a person from my background, I'm sort of at the neurotic end of security. For me, disruption has always been a bad word. You want to disrupt this? It sounds to me like you're not thinking about security, because security has always been bolted on. If you want to make rapid change, I feel that we, as this sector, need to also sort of almost be ahead of you. For me as a researcher, especially I'm a professor of forensic computing, digital forensics, always worked with the police, and always wanted to say, What will the bad guy do with the next device or system? Where is the evidence? Where is the intelligence? This seems to be, the exponential growth makes that almost impossible for me. So I'm not going to go much into this, but it's the characteristics connected to the internet in many different ways. Problems with power management. Are they just endpoints on a network? How could we secure those endpoints? If there's limited functionality in these devices, does this make the attack surface smaller? We can talk about these in groups, I guess. So the challenges that we have, security vulnerabilities in operating systems, hardware, long life, may be covered by stringent regulation, but are not at all. Examples that have happened were the attack on Krebs, which is a distributed denial of service attack. But the one that amuses me the most, because I see the direct parallels, if you excuse me, with defence uses, is the anecdotal story of internet-enabled trackers on cows in the Netherlands and a denial of service attack by using the trackers on the cows. If we put sensors on platforms and people, I foresee this could be the future. Thank you.
Thank you, Jill. Okay, our second speaker is Professor Renping Liu. He's at the School of Computing and Communications in the University of Technology, Sydney, where he leads a network security lab in the Global BIG at a technology centre. He was previously principal scientist at CSIRO, where he led wireless networking research activities. He specialises in network design and modelling and has delivered networking solutions to a number of government agencies and industry customers. Please welcome Professor Renping Liu.
Thank you. It's a similar topic, thank you, Jill, as Jill, but in a slightly different angle. So the history, going briefly, so 70s we see telephone lines, remote monitoring, and in the 90s, the IoT, starting with the wireless technologies, machine-to-machine wireless sensor networks, and in the 2010s, from recent 5 years, IoT really taking off because of these various enabling technologies and maturity. And then by 2025, predicted 100 billion connected IoT devices with 11 trillion economic impact. So 2040, and in the morning, Alex and Hugh has already talked about a lot of scenarios, and so that's a topic for the workshop. We are going to explore further. And here's the various applications. I won't go into too much details. Essentially, that's the sensor information going in, and then the action going out. So that's the application, various application in various areas of the IoT space. And talking, I'm like a professor in the technology. I like to talk about technology, right? And in terms of IoT technology, I draw a map, which here the x-axis is the data rate, the y-axis is the range, and look at this one. Where does this technology go? And at the beginning, Bluetooth and Zigbee and this body area network technology, that's going into the very lower end of the corner. And here comes the Wi-Fi, and it has some potential use in the IoT, but not exactly. Wi-Fi, of course, going 11N, AC, and AD, going to the way of the higher bandwidth. But from the .11 AF and AH, it's going into the IoT technology spaces. And here comes the 4G. We know that 4G can be used in IoT technology, although not specifically, but vendors are designing and developing technology into the IoT space with LTE-M and NB-IoT. And of course, as mentioned by Hugh this morning, and the 5G development will cover all of that. So quickly go through the architectures, IoT architectures, and from the very simple device to device, as you use mobile phone to control your light or control your onboard devices directly, that's use Bluetooth or Wi-Fi direct, or you can use in the home hub scenario, that is a device to gateway, then through gateway to the internet architecture, use mainly Wi-Fi, Zigbee, or Bluetooth technologies. And going further, that's a device directly to the internet technology. That's either use the LTE-M, NB-IoT, or 802.11ah. So that's roughly going through the IoT history, application, and technologies. Now going into the IoT security space, which Jill talked about, and slide I'm going, as promised, a slight different angle. The new challenges in IoT security, this is one of that is massive scale of devices, so hundreds of thousands within one development. And the problem is they have almost identical devices. What's the problem with that? If we break one, and so hundreds of thousands of devices yours, and you can do anything with that. And we have seen last year, this biggest, one of the biggest cyber attack with the IoT devices, right? We all know what happened in October last year. And say how to solve that? Cybersecurity for IoT considerations. For the, the cost and versus security, because there are massive devices, it's unlike a mobile phone or a computer. These are massive small devices, and how do we design these small devices? And we have to consider the cost. And so the trade-off between cost and security, and you need to know what can be trade-off, what can't be trade-off, right? And for these small devices, you need to know the feature of these. They are static, they are small, they only do small, tiny specific tasks. So you need to know these specific features so that you can design the lightweight security, specifically targeting these devices for these developed deployments. And the data confidentiality, integrity, and access is also important. Jill already mentioned that quite a lot. I won't go into much detail. And the field upgradable, right? You deploy a sensor, it'll be there for 10 years. How do you upgrade that? Our mobile phone is keep receiving upgrade all the time, and for that, how do you upgrade that? And also, when it finished, when 10 years time, when it finished, can the device destroy itself or not? If not, it will be a hidden hazard. Right? And privacy and trust are also a very important issue for the IoT, because if the data can't be trusted, right? Then the IoT, if your privacy can't be protected, if the data collected can't be trusted, then who will use this data? Who will give this data? Then there will be nobody using this data. Then this IoT technology, although you've got this fantastic enabling technology, but without all of this, privacy and trust, this technology will become a white elephant. One of the solutions which we are currently actively working on is using blockchain technology, to blockchain-based IoT technology to give the privacy and anonymity, to provide the authentication, to deliver the tamper-resistant data, to deliver the integrity and the trust. And also, because of this blockchain distributed technology, and we can have that resistance to code compromise. And here's my brief update on the IoT technology. Thank you.
Thank you, Renping. Unfortunately, Renping has to leave us at this point, but thank you for your insights. Okay, so the next speaker we have this morning is Professor Massimo Picardi. Professor Picardi is Professor of Computer Systems with the Faculty of Engineering and Information Technology at the University of Technology. Since relocating to Australia from Italy in 2002, he has been the principal investigator of a number of advanced research projects, including 2 Australian Research Council discovery projects and an ARC linkage project. Please welcome Professor Massimo Picardi.
So the only thing that we can know for sure about 2040 is that is in 23 years from now. This is something we certainly can agree, and the reason for pointing out that is that there are essentially hard to make provisions, forecasting what will be there then. We don't know. Some of the predictions we can make today will probably be unmet, but other predictions will certainly be surpassed. So what I believe is a 2040 scenario, which is the theme of this workshop, is probably just an exercise. My exercise is far less futuristic than that of Dr. Bradlow before. So I also see lots of driverless cars, lots of drones. Even if there will be accidents during development, exactly like in aviation history, they will not stop the development and the progress of these technologies. There will be more inconspicuous gadgets such as Google Home, Amazon Echo that will restore our fridge and do things for us, respond to our vocal comments. There will be augmented reality glasses. There will be all the things that Dr. Bradlow has mentioned before. As for what social media, I don't think there will be separate social media like Facebook, Instagram, but there will be a social media continuum, and we will be continuously immersed and interact with that. So in this scenario, where will the data come from? The data will come from unnumbered sources. The data will come from the driverless vehicles. The data will come from the street cameras. The data will come from sensors in buildings and infrastructures. The data will come from all the wearables that we will be carrying with us. There's plenty of sensors in nowadays mobile phones already. Some of them will be related to our health and physical status, such as heart rate, glucose, and more so. There will be cameras and microphones pretty much everywhere, in all these wearables, but also in the augmented reality glasses that we'll carry around. We will see through, we will see the apps, but also the cameras and microphones will see and hear what we say and what's around us. There will be all the data from the social media, all the data from the apps we use, all the data from our online transactions, and there will be the data from humanoid robots. I'm pointing to Ian because I presume there will be some mention of them in his talk later. So we're all used to this idea that video surveillance is somewhat concerning, and we discussed video surveillance in social context as well. We can see some form of perhaps pareidolia, the fact that we can see faces in objects. That's what perhaps we see in the camera on the left, something that is a bit intimidating and looking at us. But what about that cute robot on the right? I mean, that cute robot wears exactly the same sensor, plus it's got legs, and it can move about and can sense much more than conventional video surveillance has done to date. So for me, the question is basically leaving for a second aside all the extremely important aspects about the data that include ownership, ethics, privacy, everything about infrastructure of data like storage, communications, integrity, reliability, trustability, and more so. The main question that I'm raising myself is how we will be able to make sense of them, how we will be able to make sense of these large amounts of data. So we have to look at something. We have to look essentially at machine learning, at recognizable trends in nowadays machine learning. And the recognizable trends are very clear. There are two trends. One is deep learning, mentioned before, and the other is reinforcement learning. So deep learning is pretty much the old neural networks of the 90s, just they got more layers. And the advantage of having all these layers is that we can do a lot of recoding of the inputs, and then we can basically pretty much use any of the conventional machine learning techniques for the output. So we can have the advantages of the old machine learning plus a lot of other advantages. But deep learning comes with a caveat, the fact that it requires very large amount of training data. And these training data not only need to be collected, but need to be annotated, need to be supervised by humans to tell what the ground truth, what the reality is in those data, so that the automated system can learn to predict it. And also something that we technically call a loss function, which is simply a measurement of how inaccurate is our prediction compared to the ground truth. So that's somewhat limiting, not just because annotating data manually is time-consuming, but is also subjective and arbitrary to a degree. So there's a call, or in some cases, like for instance, applications of web designing a website. Do we know what is the ideal website? What is the ground truth of that website? Pretty much no. Also, different people would have different ideas about it. So all we can collect is feedback. And there are scenarios essentially where these loss functions are not available, large amount of annotated data are not available at least at once. And therefore, reinforcement learning is the other mainstream in today's machine learning, comes into play. It's very suitable for streaming scenarios, online scenarios, evolutionary systems. We can look at this model. It's not so important to look at the details of the model. What we got here is essentially some measurements, some latent states, some actions, and the notion of a reward that can be immediate or long-term, so that the agent can plan against it and develop in the future and act according to this intended reward. And technically, there's lots of things that could be said, but we obviously don't have time. So this notion of reinforcement learning, it obviously comes along very obviously with robots, physical autonomous systems, but also has been used very effectively in other fields like computer vision, natural language processing, website design, business decisions. So it's actually very ubiquitous. Only on reflection that the fact that agents are physical, yes, but agents can also be entirely virtual. And exactly the same principles can drive their design. My question is, will agents be sentient by 2040 or 2050 or so? This is a big question. I found this essay, I found it extremely interesting. It's a bit thought-provoking, possibly controversial. It states that even nowadays, reinforcement learning agents deserve some level of moral attention. We cannot just, probably in the future, if these objects will have some form of awareness and sentience, we will not be allowed to mistreat them, essentially. So that's really looking to the future. As for ourselves, what we do at UTS is a bit less than what I spoke about. We do essentially structured prediction, which is a simplified form of reinforcement learning. We do text classification, we do image analysis, we do video surveillance, computer vision, and a few other things. This is an example of a text classifier in Farsi. There's been a lot of attention, of course, to English, but other languages are equally important. This is a system that can take a video, find what's going on in the video, and summarize it automatically so that people can gain a quick understanding what the video scene is about, and can be used for teaching. Here you can recognize the recipe and find the main frames of the action and use it to teach maybe the future chefs. So skipping on this, essentially, research is becoming the more and more a federated effort, is becoming the more and more interdisciplinary. So in the center I work for, we have machine learning, yes, but we also have lots of other things like Internet of Things, security, cloud computing, because you need all these together to be able to draw a bigger picture. And of course, you will need to draw from other expertise in universities or elsewhere And so that's what we try to do, and we'll try to do with you when opportunity arises. Thank you very much.
Thank you, Massimo. Okay, our next speaker this morning is Professor Ian Reid, who is a Professor of Computer Science at the Australian Centre for Visual Technologies. His research interests span a wide range of topics in computer vision. He's concerned with...
Together under the auspices of the Australian Academy of Sciences and sponsored by DST, chaired by Hugh Durrant-White. Hugh would have presented this work today, but he's in the last 2 weeks moved to the UK to be Chief Defence Scientist in the UK. But so this working group came together around about less than 12 months ago and comprises people from academia who are experts in various aspects of autonomous robotics. And perhaps many people know this already, but a little brief history lesson. Artificial intelligence, computer vision, robotics, all really started around about the same time, but diverged. And one of the reasons that they diverged was that people realised pretty rapidly that computer vision just wasn't up to the task of providing useful, timely sensory information for robots. And robots could do all sorts of things that didn't require sensing the environment. The reason this group has come together is that what we've seen over the last decade or so is step changes in improvement in various areas. Things like computer vision, sensing technology, artificial intelligence, and so forth. And I suppose one of the findings of this group is that Australia has world-class robotics research. So the objectives of the study were really to understand what's the current state of the art in autonomous robotics. Is there a vision for autonomous robotics in 10 to 20 years? How realistic is that vision, and how do you plug the gap between the vision and where we are now? So what technologies need to be developed? And this report, I can't hand it to you today. It will be released within the next few months. It's structured around 5 key parts. The first part is really an introductory part that sets out the vision and the challenges. So we have a top-level vision of future robotics, what are the positives and negatives of that, and then the key technology challenges, what's needed to realise that vision. So in particular, with the vision, that is articulated through 6 current and future application domains. I'll touch on those briefly. And for each of those, we talk about the vision, current state, and the challenges associated with that. And then we look specifically at what the technological challenges are. And we've divided that again into 6 main technology and societal challenges for future robotics. And we talk a little bit about the issues, what's achievable, and in particular, what are the hard problems in each of those areas. So the introduction of this report provides a vision for autonomous robotics and states where we are now. It talks about the key conceptual technological challenges and tries to put a lot of this in an Australian context. And I'll touch a little bit on that in a bit. But so the key points really are that the vision for robots, and I think this is a vision shared by pretty much everyone, is that these robots will be machines that serve humanity in various ways for a more productive, a safer and a healthier human lives and a healthier planet. The other key thing, and I'm sure everyone in this room is aware, that we are reaching a tipping point. Recent advances have brought this vision of autonomous robots much closer than ever before. And so one of the things that's happened is that vision that started out in the 1950s and early 1960s in places like MIT and Stanford is now starting to become a reality, perhaps having gone through that trough of disillusionment. Robots are increasingly going into uncertain and unpredictable environments, but there are also significant opportunities and significant fears associated with all of that. In many sectors, we believe that robotics are going to be prevalent in around about 20 years. In some cases, it's going to be beyond 20 years, but we're already seeing penetration of robotics into a number of areas. But I guess the other key thing that I want to touch on is that some areas are overhyped. And so I don't believe, and I don't think the panel believes, that full human-engaged autonomy is likely within the next 20 to 25 years. It will probably happen in the future, but not within the scope of say this symposium. And in some sectors, perhaps even the right questions haven't yet been asked. But we do still believe that Australia has a unique and major role to play in robotics. So I'm going to touch very briefly on the vision. So a future of applications enables us to think about what those future scenarios might be. And it drives questions around key technical and research challenges. So what's the maturity of current technology? What's the realistic future vision? And what could be done in each of these application areas in the next 20 years? And how will the tech progress? So the application areas that we looked at cover pretty much everything that you could think of. I'm sure there are a few things that have dropped off this list, but we structured the report around these 6 application areas. So social robotics, and perhaps in particular domestic robotics, this vision of the humanoid robotic helper, health robotics, clinical care, nursing, physical patient management and so forth. Transport, so we're lumping driverless cars into transport, so air, ground and sea, drones lumping into transport. Work sites, so in particular, work sites is an area that Australia has a lead over the rest of the world in terms of autonomous robotics, in particular the mining sector. And one thing that I'll draw out now, because I can't remember if I draw it out in a later slide, is that some of this change in Australia has been driven by primary industry. There are economic drivers there from agriculture and from mining, from resources that have driven this change. It's harder to see where those drivers come from for some of these other things in an Australian context. And of course we talk about environment and defence as well in this report. The challenges we've structured around these 6 critical areas. So I'll touch on sort of 1, 5 and 6. So human interaction and the role that robots are going to play is going to require a degree of human-robot interaction. And that's an area that still has significant challenges associated with it. I guess the core of robotics, as I see it, is still this vision that was articulated by Mike Brady nearly 40 years ago. So the intelligent connection of perception to action. And so these 3 key areas of action, perception and cognition. And I'll talk a little bit in a bit about the link between perception and cognition. Then of course there are various enabling technologies and the ethical and societal issues associated with robotic technology. So I'm going to skip fairly quickly over these because I'm sure you would rather hear me talk about some conclusions and so forth. Human interaction is key to many envisaged applications, and it's still very primitive in a lot of applications, in a lot of scenarios. And I guess for this audience, defence is one, where perhaps modelling human behaviour, awareness and intention, and also this idea of situation awareness, and how do you convey situation awareness that might be embedded in some opaque artificial intelligence somewhere to a human operator, and how do they interact? And that's perhaps one of the questions that hasn't really been asked, let alone answered yet. And then there are these perhaps wider things of forming relationships and so forth. I'm not really qualified to talk about those sort of social aspects of the humanoid helper or the patient carer. Action has traditionally been more advanced in the robotics than perception. We still have a number of things to overcome. Action in robots is much more precise than in humans, but in most cases it is not as agile. And so there's a whole bunch of challenges that need to be addressed. In particular, the idea of adaptation and self-repair is really only in its infancy. We have started to look at muscle-like actuation, soft robotics and so forth, but really the kind of actuation that we can perform at the moment doesn't approach the levels of precision and torque that biosystems can produce. Perception is one that's particularly close to my heart. Sensing, interpretation and environment modelling. It's arguably still the most challenging and complex problem in robotics. How do you take raw sensor data and turn it into some understanding of that environment? And really it's in this area where there have been significant gains in the last couple of years. And I just want to spend a second talking about deep learning. A few people have mentioned deep learning. The reason it's being mentioned now, it's been around for 30 or more years. The reason it's being mentioned now is that in the last 5 years, a confluence of faster processing, huge amounts of data, and better ways of training these networks have meant that we're now at levels that perhaps not at human level, but are approaching human level, as Hugh Bradlow talked about earlier. And cognition, slightly more airy-fairy, but really it's this link between perception and cognition that I think is one of the major challenges. We don't understand how to bring expert knowledge to bear on sensor data at the moment, and how does a deep learning network convey what it's understood from the environment. So I'll skip over enabling technologies and these non-technical challenges and just recap on these conclusions. So I believe we've reached a tipping point. Disruption is already happening. Full autonomy in transport, I think, is probably still 15 to 20 years away, although we're going to see some applications. I'm not sure I share Hugh's vision of the everyone giving away their cars, and I'm very happy to talk to people about that. But perhaps I will recap, or final thought. I think we can be easily overhype this revolution that's coming, and I'll stop there.
Okay, thanks, Ian. Our next speaker is Mr. Paul Hoyer. So Paul is Research Leader, Combat and Mission Systems in the Defence Science and Technology Group's Weapons and Combat Systems Division. He leads a major science and technology capability totalling 50 scientists and engineers, supporting several ADF and government elements. Please welcome Paul Hoyer. Thanks, Paul.
Good morning. I'm going to talk today about adaptive systems, and what I'm going to try and do is step back a little bit from sort of my area in defence and try and look at it from a sort of a generic standpoint, then look at it from what outside of defence might bring to it, and then talk about what the defence lens might look at it like over that. So if we talk about what is adaptive, so the Cambridge Dictionary talks about having an ability to change to suit different conditions. Collins talks about the ability or tendency to adapt to different situations. So you've got that ability, the tendency, some sort of change, obviously, and then conditions or situations that you're adapting to. If you look at that from a business point of view, you can talk about a flexible system, improves performance or its chances of survival, monitoring and adjusting its own configuration and the way it operates in response to feedback from the environment. So again, you're combining the performance and survival concepts. So you might sort of think about, okay, there's a link to artificial intelligence there. You're looking at the areas in the middle being able to monitor, adjust to adapt, obviously. And then that idea of there's an environment out there that I'm operating in, so what am I adapting to? So they're the words you've heard other speakers this morning talk in those sorts of terms. If you think about it from, I think Nigel made a comment about the type of operating system that's in use in the defence from an administrative point of view, and we talk about sort of where the military has come from, you're more likely to think about words like security, safety, hierarchy, command, control. We haven't heard a lot about that today. So we're talking about from an adaptive system point of view of saying the defence has realised that it needs to change. Technology is enabling that change. So how do we bring the rapid adaptation to an environment that's evolving? How do we bring the defence to that as an organisation? So forecasting future technology, it's far from an exact science, and we've seen a sort of couple of extremes today of opinion as to where things will go. So instead of me trying to predict as well, what I'd like to do is step back and have a look at how the needs of an adaptive system might drive where technology needs to mature. So if we just look at those 4 central activities, we can sort of step through them one at a time. Picked up sort of monitoring the environment, the idea of sensing, perception, the idea of being able to share information from different sensors to be able to extract key information, to be able to fuse that information. So we're talking about a system being able to monitor itself and its own performance, being able to sense what's happening. That's been very, from a defence system point of view, we've picked particular things that we think we need to sense about an operation or a system that we're working on, and things outside of that narrow area can wrong foot us. So if I'm trying to detect something with a radar, and my radar isn't efficient in a certain area, I need to be able to adapt to that rather than go back and rebuild a radar or buy a different product. What we're trying to do is adapt to respond to a situation. More and more several sensors together contribute to that monitoring. So we're talking about sort of broader bandwidth, IR, UV, visible, perhaps going much more into hyperspectral type sensing. The idea of sharing the data with other systems to try and get a combined performance. So I may not need to succeed, but I may be able to enable something else to succeed in what it's doing. So we're talking about third-party targeting as an example of I can provide target quality information to something else in order to achieve that effect. There's also that idea of, at the moment, we might pre-design that, but the idea of saying, look, I can't achieve my objective, but we can adapt our operation to let something else achieve its objective. And then we're talking about information extraction from that data. We've heard a little bit today about how do I pull out key frames of a video in order to very quickly get an assessment of the situation. So you can see that, the types of technologies, sensing, data fusion. Obviously, there's an implication of networking in that. The idea of those data sets being massively huge, we're talking about how am I going to dig through that in a tactical time frame. So I don't have days, weeks or months to do something. I'm trying to respond to an operation that's underway now. The next point there is adjust. The diagram I picked was from a network-centric warfare roadmap that Defence put out some years ago. And you can see the thinking at the time was, I need to get situational awareness, I need to plan something, and then I need to take some action. So it was very much around the military, gaining control of a situation, laying out all the pieces, and then executing a plan. We know from recent operations that being able to identify the landscape and kind of lock it down while I run this operation, it's not holding true. When we think about disaster relief, operation in urban areas, you're going to have the same sorts of things where one hospital is suddenly full. Right, we need to change and we need to go to a different hospital, that kind of thing. So we're talking about the awareness of the environment and also the awareness of what the capabilities of my system are. So where are the bounds of where I can push my system? Where I can, it's almost like how can I abuse my system without breaking it to achieve the end I want under the changed conditions? So we're talking about learning very quickly, making fast, accurate, optimal decisions, and then executing that course of action. Of course, in a military context, as Jill alluded to, while somebody else is trying to stop you from doing that, to defeat your systems. So you can sort of, again, we're talking about the technologies of AI. We've heard about machine learning. The other area we haven't heard too much about is that parallel and instant modelling of what's going on. So with the computing resources that are becoming available today, you've got the potential to basically run multiple future scenarios. You know, if I follow this course of action, this is likely to happen. You can, as time moves forward and you can rule out some of those courses of action, you can either spawn off new models to say, this is how I think things might evolve, or you can refine your models to say, this is what's happening as I go along in an operation. We all do that ourselves, driving to work every day. You know where the normal optimal route to get to work is, and you have a couple of backup routes to get to work. If there's a car accident, I know I can go 2 roads across and get through. That type of thing, being able to execute that in a machine to help a single pilot in a JSF while he's out there doing an operation, and having those things available immediately. That's the kind of adjustment that we want to talk about.
So reconfiguration, this is from my area in DST,
this is an area that we've been working on. You heard Alex mention lasagna today.
That's our exemplar open architecture, open source, modular system
where the functionality is largely software enabled. the open architecture and open source is allowing the best of breed components or functionality,
software to be brought into a system very quickly, updated very quickly. And the open source part of it, although you're opening up the design of your architecture to the world, you're actually then allowing a larger group of people to understand what you're trying to do, how you're doing it, and being able to very quickly bring the best aspects on board. And last couple of points there around parameterisation and mission specific. You want to try and be able to very quickly update the information that's going into the system to get that functionality. The last of our four is operations. So that's that continuum from completely human control, assistance with automation, through human on the loop, monitoring the automation, and then to an autonomous system. So that's around the cooperative cars example from earlier today. You know each other's intents and plans. And DST Group's Trusted Autonomy program is an example of building that trust in those systems. So adaptive in 2040, all of these technologies, monitoring, adjusting, reconfiguring the ways that you operate. Market competition in the commercial sector, I believe, is the way of us being able to do that smaller, faster, cheaper, and also in looking for innovative ways to combine and integrate those technologies to achieve a defence outcome. So as I said at the outset of this, forecasting technology is not an exact science. If you look at some of those technologies in the civilian market, and as you go through the next couple of days, please bear in mind what that might mean for our men and women warfighters in 2040. Thank you.
Thanks, Paul. Okay, our final speaker for this session is Professor Gurno Heiser. He's part of Data 61 in CSIRO, and his main research interests are in operating systems, especially microkernel-based systems, and their use in embedded systems, OS security and robustness issues, general cyber security, energy power management, real-time systems, and virtualization. So please welcome Professor Gurno Heiser. Thank you.
Thank you. So, IoT security, I've been asked to talk about that. So, is that an oxymoron? And to a degree it is. Like, we have all these systems that are sort of important and critical and get hacked regularly. And I have to contradict partially Hugh Bradlow here because I don't think this is something you can fix with processes. If your underlying technology is broken, then you can't fix it by putting unbroken processes on top. So the main difference between the examples I just given here and your typical IoT devices, the IoT device is way easier to hack than those things. So what's behind that? And fundamentally, it's complexity. So we have increasing functionality, etc., and reuse of legacy components, and all that, when you build new devices, leads to increase in complexity. And with that increase in complexity generally comes a decrease in dependability and security. And that's sort of a boiling frog issue because complexity sort of sneaks up on you and you don't realize you have too much of it until it's too late. So there's some fundamental fixes required. And people are sort of starting to wake up to this. This is sort of the Linux community doing some self-assessment, and the takeaway line was unsafe at any clock speed. And don't think for a second that Windows or iOS is better. It's not. So the second reason for failure besides complexity is what I call care factor. And that means, like, if you look at what drives developers, particularly in the IoT world, first is functionalities, because that sells. And the second is cost, because that helps selling. And the third is time to market, because, well, that's the same as cost, really. So that's what people worry about. And then they worry about a few other things, and maybe, if at all, down at the bottom, they worry about security. And that's why you get these disasters. And the other part of that is what actually the developers understand about. There's zillions of these IoT products being built, and the people who build them are typically, well, they probably just have an undergraduate computing or EE degree, and they may have some knowledge about the application domain, and maybe some of the hardware they're tinkering with, and then maybe something else, and maybe they have heard of security. And in average, they don't really know much about it. So really, they need to be given help. And the help needs to be, part is that processes like decent software engineering, etc., is always good, but also we really need to have help at the fundamental technology. So what could we do? Well, one is, let's just use type-safe languages, Java, Scala, or whatever you would like, which actually by definition, in a way, avoid a lot of these problems. So that's good, but it's not sufficient, partially because these IoT devices, if, as you said, they have to run on battery for years and years, overhead is deadly. It takes away battery life, so you can't afford it, and these things come with overhead. It also, particularly in IoT devices where you inherently deal directly with hardware, there is always a need for unsafe coding. And finally, it doesn't help if you have to integrate legacy code, which you have to do all the time. The other thing people often come up with, let's do a firewall. There's a lot of snakes, oil salesmen going around selling you firewalls for this, that, and everything, and you just take this firewall and security is good. Reality, it's not. Because partially, okay, the firewall introduces overhead. The more sophisticated it is, the more overhead. That's, again, depress your battery life. It may actually increase your attack surface because it's more complexity in the system. And finally, it doesn't really help against a lot of the attacks. Just an example, one of the recent car hacks was someone sent a carefully crafted JPEG to a reader or an MPG that triggered a buffer overflow in the underlying software. Your firewall is not going to protect against that because it's just sending valid data which exploits a bug in the underlying software. So firewall for this is useless. I don't mean to say you shouldn't have firewalls at all, but they're not the solution. Fundamentally, isolation. And you need a proper structure, proper architecture, a system which distinguishes between the critical bits and a discipline that really keeps those small, simple, easy to validate, and the rest a system which contributes to the overall system mission that is less critical, and if it falls over, then you can still survive. And then you need some hard separation and control communication between those. So, okay. Fundamentally, that means you need to provide some core properties. And the core properties is security, integrity, availability, and confidentiality. For safety, there's also timeliness, and they're all isolation properties. So you need a technology that gives you this isolation. And it needs to be reliable, because anything in the end that's not proven correct is not. That's of a lesson learned in the 70s, really. And in particular, that means just testing, code inspection, reduces your fault densities, but it's not going to eliminate them. What you need is actual proof. And this is actually doable these days. So, as an example, we have this SEO4 microkernel, which we developed in Data61 and its predecessor NICTA here in Sydney, where we have an operating system that's written as anything else in C, and then there's an abstract description of its functionality. So, this is a description of the functionality in a mathematical logic. And then there's a formal proof, machine-checked proof, that the implementation satisfies the functionality. In that sense, it's a bug-free implementation. And then there's a further proof that shows that the binary that actually runs on the hardware is a correct translation of the C, so we don't have to trust the C compiler. That gives you some assurance, but it doesn't mean the abstract model is any good. It only shows that it's correctly implemented. So we need further proof, and we have those, that the formal model actually enforces these isolation properties. So it enforces confidentiality, integrity, availability, provably, and that proof goes all the way down to the hardware. And then there is some temporal properties as well that allows us to do hard real time. There's some exclusions, which I don't delve into, I just put them up here. And it's blindingly fast, faster than any other comparable system. So this is nice, sounds like a nice academic project. Is it useful? Turns out it is. And I just came back this morning, actually, due to some weather-enforced delays from the US, from the final demo day for the DARPA HACMS program, which went for almost 5 years, which was essentially about taking this kind of technology and putting it into real-world systems. And specifically, what we had was a bunch of research vehicles and a drone and a autonomous robot platform where we had the freedom to basically re-engineer everything from scratch and do use this as for the research. And then we had commercial vehicles, real-world systems that are out there deployed or deployable, a autonomous helicopter built by Boeing, and self-driving army trucks, which are already driving around Detroit these days. And we retrofit those with this technology. And DARPA had a team of professional hackers, penetration testers, which initially had no problem owning these systems. Basically, they took a day or so to break into the helicopter, and the trucks were not much harder to do. And after putting this technology on there, which means really re-engineering the existing system in a process called seismic security retrofit by the DARPA office director, we could actually make them extremely hard against cyber attack to the point where the professional hacker team could no longer break in there. And, oops, I thought I could, not sure how to start this video. It's starting. Okay, so this is what happened a year and a half ago when this helicopter first flew on SEL4,
and rather than trying
the first demo flight. And in the meantime, what happened last week was sort of the final version where it's shown where they actually conducted an in-flight attack that was foiled by the technology. So the bottom line here is there is some really disruptive technology that's going to completely change the way you build critical systems. And this is absolutely unique and world-leading technology, all developed here in Sydney. And the US military is keen to deploy it in across all the forces. There's development projects either in train or about to start up in a range of systems. And Alex mentioned the cross-domain desktop compositor, which is a joint project we have with DST before, which is present in evaluation, and that's built around SEL4 as well. Thank you.
Thank you. And thank you to all of the speakers this morning. So we now have time for around 30 minutes of questions and answers from the floor and from the panel. We'll need to use the microphones for all questions and for all answers.
Due to the streaming, so if you have questions, please make yourself known to the people walking around with the microphones, and we'll start the Q&A session. Somebody like to start? Yes, in the front here.
Thank you for that. Yeah, it is. Thank you for that. Some very interesting presentations there. My name is Sanjay Mazumdar from the Data to Decision CRC. So we do big data analytics for national security. One of the phrases we often use is just because you can build it doesn't mean you can use it. And that's basically to refer to the fact that with these technologies, disruptive technologies, there's the legal, policy, societal impacts of all the technologies. I was wondering if I could get some comments about how you see some of these disruptive technologies being adopted and some of the opportunities and challenges that it poses for society, law, policy, regulations, etc.
Is this on? So I can't give you a very clear answer, sorry Sanjay, but it's a very interesting question. In many cases I think that the legal things are falling behind the disruption. If I think particularly about autonomous robots, it's starting to catch up. I mean, you're seeing that in certain places, even within Australia, some of the states are putting legislation in place that will enable things like autonomous cars to operate on roads. Even that doesn't necessarily address some of the societal challenges. If I could go off on a little bit of a tangent and expand on something I was thinking about before, which is there are clear societal benefits. For instance, if everyone were to give up their cars and we just had a fleet of autonomous vehicles taking us everywhere, which is the vision that Hugh projected for 2015. Personally, I can't see that happening because I think people like their cars too much. And so one of the things that needs to be grappled with is the interaction of autonomous vehicles with human-controlled vehicles on the road. And so
I can see there being a fixed point where you say you can no longer drive your car, and it's not clear to me how you manage that transition period. Perhaps pass over.
Can I make one point? I think there's also the issue which we've started to grapple with is about, can we call it the public discourse, the public debate on cybersecurity. There's certainly research in the UK which is ahead of us, which is trying to understand how does society understand this. I think for me there's evidence in a part of government which is now suggesting we must not use the word cyber attack. We can say event, but we can't say attack. That is a bit challenging, but the rationale that underpins it is to do with fear. So I think that we need to have a mature public debate in a democracy about issues with cybersecurity, which have very often been obscured, and I think that can be based actually on mature academic research.
So my view on this is that we live in a market system, and we used to let the market control everything, right? And we've done very well overall in this, but there's some cases where the market fails, and security and safety are classical market failures. For the reason I've given you earlier when I talked about somewhat tongue-in-cheek about how devices are developed, but there's a lot of truth to that, right? People put security last because that's only a cost, and there's no demonstrable financial benefit to them. So that means there's not going to be a change for the good happening until regulation comes in. So this is the place where regulation is absolutely essential. You need to make people responsible for the failures in their products, being security or safety failures. Until that happens, we're going to keep on building more and more insecure and unsafe systems.
So if I sort of come at it from a defence point of view or a military point of view, so systems, in the past we've gone through this validation, verification, get to a certification to be able to use a system. Then when we go into use a system in a particular area, we have rules of engagement. And then as we've found operating in the Middle East on the ground is that cultural engagement has been very important. So from that idea of a disruptive technology, we've quite often found that technology is way in front of where we are from a certified system, from establishing rules of engagement. The idea of making the military much more agile, much more adaptive to an environment questions how we do either how we do that much more quickly, or how we get to an evaluation of the risk versus the payoff. So in a commercial sense, what's the risk of going to market now versus the risk of going to market in a year's time when we've been able to retire some of those unknowns in a system. So, I think it's fertile ground basically for defence, especially now that we're looking at defence as a joint force. So we're saying we're not operating as separate forces that might talk to each other every now and then. We have a single point that says we want to achieve this effect. These are the resources we've got. These are the risks we face, and this is the end state that we seek.
Question over here.
Hello, David Miller from Power Development Centre. Do we need an idiot's guide education process for our regulators? I put it in the context, I would love to see that desktop translator across the domains. That's something that's been a holy grail in air operations centres for years, but in those air operations centres they have to have mechanical jigglers because Defence isn't allowed to not have a screen that's got our time lockout on it, and we still operate Windows 2003. So how do we get our regulators to make informed decisions? Do we need an education process, a formal education process for policymakers?
Okay. I think what you're seeing now in the Australian government and the Defence Department to some degree is you know, we've kind of lived that very long road to bringing new capability on board for defence, and especially as someone in an R&D community in Australia, you know, we used to joke about the fact that we'd have to sell our ideas to the US before Australia would buy them back, you know, that kind of thing. I think what you're seeing now with the Next Generation Technologies program, with the innovation pipeline, is the recognition now that we can do this in the country. The other thing with the first principles review of defence is to say defence realises that it needs to reach out and bring things in more quickly. And I think part of that's come from the operations in the Middle East, where, you know, we arrived, we kind of had equipment that we very quickly had to modify to suit. We very quickly realised it wasn't just the 5 nations that usually work together. So there was a lot of reaction at that time, which I think now is being built into our business model, and the idea that digital disruption, typically we'd buy a piece of kit and operate it for 30 years and maybe update it once. The wish of the JSF program was to update the software every 2 years, and even in that we're saying we want to try and update the parameterisation of that system much more quickly than that. So how do we get through that? I think you've got people in the right place now that are starting to realise that those are the roadblocks, and the way that technology comes on board. I also think that we're now starting to see that you've got Australian industry that's demonstrated that it can do some of these things. So the idea is that we don't need to always go to the same players. We can start to look at more agile organisations, ideas that we can fast track through an innovation program, and then you've got the people inside the Defence Department now that have the power to say, I want to fast track something also into service.
I just wish to say that... Can you hear me? Just Australian universities have, all of them started a lot of programs in data science, innovation, and I presume and I hope that in 3 years from now or so, the situation in terms of resources, of new generations and people who can make this happen will be significantly different from the shortage of skills that we have experienced until now, until the present days. So I hope the universities are responding to this challenge, essentially, and there will be visible effects very, very soon.
Yep. No, okay. Thank you. Great panel. Really enjoying their contributions and the conversation. So I just thought I might comment on the Gernot's idea about the security of systems. Certainly in some of our systems, such as in banking, Australia is a world leader. Some of the technologies that we have developed for our security of banking is great. And you can see that we can rely on that, and of course they are worried very much about the integrity of such systems. But we've also seen in the last 10 days, last week, what's happened up at Airlie Beach, where people have not been able to go to an ATM for more than a week. People don't have electricity for at least over a week, and may not even get electricity for another 2 weeks. So this is a sort of disruption caused by natural disaster, but you can imagine unnatural disasters. Where we sit here in defence, we worry about that, preventing that from happening, or potentially being able to cause such effects. So you can see what it can do, and so I'd just like to see what your comment is about the technology. Even though you might see that Australian banks are very secure, but then you have a disruption of weather and what it can do, but that's basically disrupting energy effectively. And I'd like to get a sense of what the panel thinks about disruption from the point of view of physical disruption to systems caused, which when we depended very much on digital systems.
Yeah, since you directly addressed me, I should take this up first, I think. On the one side, this is sort of a cost-benefit issue, right? So as long as your physical disruption is local, then you could say, well, it's probably not worthwhile put too much effort in making it really available under all circumstances, because the damage is limited compared to the cost that would take. Of course, you can think of much more widespread disruption, for example, autonomous cars, right? If someone managed to commandeer the whole fleet, they could really create widespread disruption at a national scale, and that would be pretty disastrous. In principle, solutions for this are known, right? We know how to build fault-tolerant systems. That's been all done in the 80s and 90s. And they need to be put in place where it's actually worthwhile. But in the end, you really need an informed decision of how much resilience you need in order, and what the cost is, and what the right balance between those is. I think in principle it's a solvable problem, and the fundamental solutions are known.
Thanks, Alex. That's an interesting question, and I guess I agree with Gunnar that the issue is the one of resilience. If I'm honest about the nature of what I do as a researcher, and also in the development of curriculum, I see the complexity of the situation, and I also see us as a country lagging behind in terms of education. We lag at we're way back behind the UK and the US. So I often feel that what I'm doing is a knee-jerk reaction to the basic issues of teaching people about cybersecurity, trying to sort of support defence and government industry with patching, bringing people from the analogue to the digital world and securing it. We did have a lot of emphasis in government, particularly I can remember with Mike Rothery, who did die unfortunately, about resilience. And I feel that perhaps we need a new focus on resilience to deal with the issues that you raise. They're there in the standards. We often teach the standards, but I'm not sure if we actually implement them even in our own thinking.
Hi, Kate Rowe from DST. Massimo, you mentioned about the question of will agents be morally relevant? I know that's not a new idea, but when we put it together with this, the market-driven issues with introducing cybersecurity, security being at the bottom of the developers list, that the moral questions we know has usually been the realm of politics and ethics, which is a timescale, an order of magnitude out from what we're talking about here. So my question is, how do you see that playing out, and who in this system that we're all part of might be addressing those questions?
So it's a very big question. It's not obvious the answer. You will see a lot of social disruption, not just from technology or as an adverse reaction to technology. This was beautifully stated in Dr. Braidlaw's address this morning. More to come, the more technologies seem to become a bit like the big brother, and the more people will, perhaps first will be the populist parties, I assume, that will take a stance against technology and will start moving away from it or creating a social reaction to it. Already there has been for video surveillance, which is understandable. So I don't know really how this will play out. I really don't know. What I was trying to say before is that is almost an opposite point of view, which is if we are going to develop robots which are so sophisticated to embed something that we can recognize as a form of life, or some sort of artificial creatures we can inflict pain to, we should start thinking seriously about them as well, but that's obviously a bit far-fetched and to be seen.
So I just want to add very briefly, I'm not qualified really to comment on the ethics, but I would put in a plug for the work that was done on the expert panel. Rob Sparrow, who's an ethicist philosopher, was part of that panel and dealt particularly with the ethical and societal aspects of robotics. So.
Good morning, I'm Paul Manzi from Department of Defence, Military Strategy Branch. Great presentations. One thing that is very obvious to myself, maybe to other people in the audience here, is that the technology is certainly going down pathways where current industries are basically going to be wiped out, and obviously a lot of jobs will go. We also see that the population of the globe is actually increasing, so there is certainly a degree, a delta, between the jobs available we have today and the jobs of the future. Now, I acknowledge that there will be some jobs created by the new industries, but will they be sufficient to fill the vacuum that will be created by these new technologies? So my question is there comparative studies looking at these social dangers with regards to a population that is no longer employed, maybe feels disenfranchised by the technologies being brought in, and that certainly gives a security question with regards to how we manage that particular phenomenon.
So I'm not aware of any studies that would address exactly the things that you're asking there. Obviously, there are studies that many people will have seen, including the one from Mike Osborne at Oxford, looking at the number of jobs that would be impacted, and putting that number at something like 47%. And without wishing to get political, I mean, we're already seeing a lot of that disenfranchisement that you're talking about. I'm not sure that trying to hold the dam wall back is a solution, but you're absolutely right that that perhaps can get added to the list of societal and ethical things that politicians and regulators and so forth need to be thinking about in the context of what do you do? The transition is going to be much more significant than the transition that we've had over the last 40 years, where there has been a shift in the way people are employed and people have more leisure time in the West and so forth. The disruption that's coming is going to be a much bigger step change.
I have seen studies way back to about 2005 which have been done in Australia using, complex adaptive systems to look at population shift. I'm remembering about Western Australia. It might have been to do with mining. I'm not aware of anything that's current, and as I think I'm agreeing that should be something that we should be doing if we sincerely believe what we're predicting. I think I see myself, I know my own little tiny piece of the world, and this is the first time I've thought about the implications actually of my work on the issue that you're dealing with. And so I wish we could get our act together and collaborate more and think far more broadly about the things that we're actually touching on now. And perhaps this is the opportunity to start research which draws on a whole heap of other sets of skills and knowledge.
John Mackenzie, Force Design Defence. My question is initially for Professor Reid, and it's about our forecast of what is possible. So it strikes me that you talked about some of the market drivers for getting autonomous robotics as being, in select areas. I mean, it also strikes me that one of the things that's potentially slowing that down is the ethical consideration that we put around the development of those sorts of systems. And I'd be interested in your view as to whether state or non-state actors who don't share the same sort of ethical framework might accelerate that sort of process. You talked about what might be conceivable in the horizon we're talking about. Would it potentially speed up if you took off the ethical brake?
Tough question. And I think you're probably right that if you took that brake off, things might speed up. I'm not sure we're at that stage yet. I think we're still at the stage where the vision that we might push out to 2040 or 2050 is not achievable with current technology, and even without ethical considerations. Certainly in that sphere, the autonomous robotics sphere. I think that we're still struggling with certain aspects of AI, huge step changes in the last 5 years, but we're still struggling with that, still struggling with materials and so forth. I think there are other areas where ethical considerations are a potential break in brake on that development. Things to do with genomics and genetic engineering, various other aspects of technology that are also potentially disruptive, are things that are perhaps happening more slowly because of either ethical considerations or interest groups lobbying against them and so forth. I don't see that happening yet in autonomous robotics. Maybe in 5 to 10 years, when some of these significant problems have been overcome, that will be a significant consideration.
Also, my world and your world, when they come together, are a bit strange because we have archaic ethical systems in universities. So even if I declare that my work is in aid of national security, I once was punished by being on the ethics committee and sat there with psychologists and pastors. And I much prefer the defence approach. And if I have defence students, I send them to defence. But the reality is the industry has huge data sets that I would like to work with, but I can't access them. My colleagues in America say, don't worry, Jill, I'll get it for you. But that's also unethical. And in fact, as a member of IEEE, ISC Squared and the Australian Computer Society, I signed ethical statements about all the things I would and wouldn't do. So that means I'm less able to serve you, especially in terms of cybersecurity, intrusion detection, data sets. So all I can do is have a traffic generator and generate my own, knowing that the publications are not really valued because they're synthetic data sets. So it's something that somebody needs to address, but even as a professor, I can't deal with it.
I was just going to sort of touch, I guess, pick up on Ian's point around taking that cultural handbrake off, and effectively, even if that's occurring from a red teaming point of view, and saying, okay, there are, from a military point of view, there are adversaries that don't share our cultural beliefs. So the idea of saying we've got a fleet of autonomous vehicles, what would happen if you took control of the autonomous vehicles and never mind running them off the road, but actually use them to ram hospitals or something like that. The ability to try and red team from a negative cultural perspective may be the way of hardening systems, of progressing systems, of looking at technology adaptation, that we then say, well, our cultural bounds are here. We understand how they might be used in this way, but our cultural bounds are here. Of course, then you get into if it's possible, someone's going to try and do it. So, how do you then apply that cultural break as a nation versus how other people use a system?
Nigel McGinty, DST. I'm just interested in security being integral, and of course we've heard some examples here of why it needs to be integral with a system as opposed to a practice. But I guess some of the work is based around a formal, endorsed software capability, right? Where actually the software industry is agile, it's quickly developing, users and customers are demanding more features more quickly. So, are the practicalities that we're still going to have that industry requirement for a really quick turnaround, and that only the secure operating systems are applied to bespoke applications? So,
I think that was directed at me. Yeah, I mean, this sort of formal verification techniques, even though they go back 40 years or so, their practical usability is only just starting to happen. The way to make these approachable and widely usable is to build them into development frameworks. And for example, the US Department of Homeland Security has this CPSSEC, Cyber Physical Security, Cyber Physical System Security Program, under which it funds, among others, a company in Minneapolis that builds frameworks that allow manufacturers of medical devices to build them securely. without increasing their development costs, basically. So just a framework that allows them to build security in, and obviously it has to do, it's built around model-driven design, so you start off with a high-level model and refine it down, etc., and it integrates SEO4. So I think this is the way to get this technology out there. At the same time, we have active programs on reducing the cost and the barrier to application or to usage of these techniques by just making them more like standard programming and just using languages that are specifically designed for providing this secure system or lend themselves to building secure systems much easier. Again, they need to tie in with model-driven design. So at the moment, I think we have the beginning to a solution. We have the fundamental core building block to that, and way more needs to be done, and it's going to take at least 5 to 10 years to sort of make that a really widespread reality. But I think the roadmap is clear, and in principle, we know how to do it.
Okay, any more questions? Yes, my friend. Sorry, we need a microphone just behind you.
It's a key point that Keynote makes, and relates to this idea of or asking the question, should we be taking off the cultural handbrake, reducing the ethics to allow things move forward? I would suggest maybe it's the reverse. Maybe we should consider putting the handbrake on, because aren't we already acting unethically by allowing all these unproven systems out there? We're creating this potentially psychotic internet of everything, and nobody's taking the leadership to enforce some standards. So shouldn't the first step be to implement or enforce or mandate a level of quality standards in terms of security and integrity?
I couldn't agree more with what you're saying, and it's totally in line with what I said before in sort of the role of regulation in forcing people to do the right thing. And fundamentally, this needs to be happening in the market context. So really, it's about making security and safety an actual cost on your balance sheet, or the lack of it, an actual cost factor. And that allows people to actually do the market thing in producing secure devices rather than this market pressure to producing unsecure devices. But of course, it comes back to the earlier question of our regulators are basically clueless. They're way behind the technology. They don't understand it. And sort of it comes back to the question that was asked earlier. How do we educate the regulators?
And that's what I was saying too. Perhaps I didn't say it clearly enough, but the bad guys have already realised this is not controlled, they're not secure, and if you want to make a political point and attack Krebs, because who was he criticising? Can't remember, but he was criticising some group, so they attacked him through cheap Chinese web cameras. And if somebody else can actually create a denial of service on cows with trackers around their necks, well, I'm just thinking of all those platforms and people who are going to be wearing the sensors of the future. Because if you can attack via the cows now, what can we see? I'm sorry to be negative, but I see negativity here, huge negativity, and it feels like very often that nobody is listening.
So, I suppose working in defence for some years, I've sort of seen the idea of standardisation from a regulator's point of view. You know, the defence had their MIL standards for years. They actually abandoned them because they couldn't keep pace with the technology pace of the 1980s. So, you know, our technology pace that we're talking about now, trying to standardise and lock down something is probably not going. You know, you're always going to have that. It will then provide the handbrake basically on technology. Educating the regulators. If you took that out as educating the enablers and saying, look, the people generally have an understanding of the impact of insecure devices, have an understanding of the impact of the potential impact of adverse use of those devices, rather than talking about regulating and trying to basically impose a number of rules on it. Then there's the idea of is it accountability that you're actually looking for? So if we're going to produce a product and to say, okay, this is how you are accountable for that product. So then it comes down to an organisational decision around risk. You know, what have I just built? How do I think it's going to be used? And then what's my accountability for the way it could be abused, if you like? So there may be a model around education, accountability for things that are on the marketplace, and the idea of what is it that you're, how far do we think these things are going to go? Things are going to go at a particular point in time. Trying to be, as a nation, agile. Australia, I guess, years ago was touted as a country that was very quick to pick up on new technology. So we want to still be able to do that as a sort of a large country with a small population, to be able to use technology for our benefit, but then also understand what is it that we're turning on, if you like, as a nation.
I think we've just about run out of time for the panel session, but there's going to be plenty of time to interact with the panel and other speakers today over the break. So please join me in thanking the panel. Okay, I've got a small gift for each of the panel members, so thank you very much for your speech today and for starting the conversations that we will have over the workshop session. And I'll hand over to JP in a few minutes to facilitate the workshop. Thank you very much. Thank you. There you go. She got logistics right. Thanks. Thank you. Thank you very much. Thank you. Okay, JP.
All right, folks, a fair bit there already. Some of you haven't read my script because we're already diving into my workshops for tomorrow, but great conversation. So at least I know that the topics and whatever that we've kind of decided to kind of embark on are pretty close to the money. Look, so this first session is about brainstorming kind of what technologies are possible, and it's about taking kind of the ideas that are already starting to be stimulated and have been expressed in in various kind of forms, and putting a little bit of concreteness around them, using the expertise that's in your table. So, and we basically are encouraging you to go as far or beyond your comfort zone from your table's expertise, either to stay just in the expertise that you find in your table, or to go kind of to wider than that. And it's around information technologies or information concepts, can be either, that are going to impact, in the 10 to 20 plus year time frame. So that's the first part that we'll be seeking to do. And then after lunch, we'll actually kind of get you to kind of prioritise those a bit more. So just to give you a way, a vehicle, I suppose, of doing this. Push the green button. So you'll see kind of the very high-tech post-it notes on your tables there. So first of all, in your tables, we'll be looking literally just to kind of, brainstorm yourselves and per post-it note, either a technology idea or a concept as such, and actually put those down. Now, in order to put a bit of order to your tables, you'll need a table lead, a syndicate lead. So that's probably the first thing that you actually need to do in your tables is appoint a table lead. The idea of that table lead, you'll be the person that just briefs back. It's not an onerous task, but we will get you to kind of brief back. So please, in your tables, appoint a table lead. Good tip. Appoint a timekeeper as well, somebody just to track the time so you don't go into lunch. And if you haven't got somebody identified to just kind of take notes and record, then please capture that. So we're looking for post-it notes. Think about what's possible, as Nigel discussed earlier in the morning. What's possible, what's plausible, and if it's more concrete, go into what's probable and even kind of what's preferred, but it can be as wide as what's possible. And what we'd like you to do with those, so you've got all those post-it notes, you can do that either individually or in groups, but let's one idea per post-it note, is then put them on a timeline. So you'll see strategically coming around now, there is a whiteboard per table. So we'll get you to draw a timeline, it can be as artistic as that, out to the 20+ time frame. And we want you to just post your ideas, either technologies or concepts, on that time frame. And it's not the invention of the technology, it's when we're seeing the impact of that technology and you know, kind of at least kind of your best guess asset. So that's what I'd like you to do between now and lunch. So we've got about 20 minutes for this activity. So tables are coming around, the whiteboards are coming around. A syndicate facilitator will help your various tables, so somebody will come and anoint you. And the one table, so I think we've got tables 1 to 10 covered. So table 11, not that I have anything against table 11, you're a wonderful bunch of all gentlemen, yes. But what I'd like you to do is distribute yourselves across the other tables. So for the purpose of the workshop, please, if you're happy to move to one of the other tables, just to, that will help us kind of even things out. If you are still viewing me in the streaming land and you'd like to keep engaging, and I've noticed we're already kind of seeing a lot of feeds come in, so keep that. If you're after questions, hashtag EDTAS uppercase. If you want to contribute to the discussion on technologies, same with that as well. All right, any questions? He says, go to it. We've got 20 minutes till lunchtime.
Emerging Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies and the complexity it poses could disrupt society broadly and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring 4 main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions and others may be used through the workshop activities. This will be an exciting symposium and we hope you're able to join us for the whole event. Welcome to EDTAS.
folks, lots of huddling going on, which is very good. Lunch is here, so I'm very happy if you continue huddling, because that's always good. But by the same token, if you're happy with that your whiteboard looks something like mine, doesn't have to look as orderly as that, but as long as it's as colourful as that and has a degree of technologies, then that's great. If there aren't enough, then keep going. But lunch is served. We've got about 50 minutes for lunch, so please feel free, grab some lunch, continue the conversation. If you have a special, if you indicated a special diet requirement, those meals are over by the registration area. So have a look for, if you've noted that, please head over there and you'll find your lunch over there, and we will reconvene, he says, at, anyway, I'll tell you, it's about 50 minutes. Thank you for your participation so far, and enjoy some lunch. Thanks, folks. If I could have you all seated back at 1:30. Thank you. Cheers.
Disruptive Technology Assessment Symposium. EDTAS, Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies, and the complexity it poses could disrupt society broadly, and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring 4 main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live, and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions, and others may be used through the workshop activities. This will be an exciting symposium, and we hope you're able
let's call it three information technologies, ideas, concepts, that out of those ones in the 10 plus that you've left there, that you think are the most important priorities. And because they're the ones that I'm going to kind of ask you then to kind of take on forward. So that's the discussion that we'd like you to have in this next little period, and we've got through until 2 o'clock to do this. So firstly, there's a fierce debate about what's kind of left of the line and whether it should stay left, and if it's not, move it. And then in your groups, try to consolidate those future ones, and if there's several that group together, then do so. But I want to land with the 3 priorities, from an information technology idea or concept that we're going to carry forward. And the reason, without reading my mind, is that you will then carry those forward, and these will become your themes going forward. So that's the task. Now, this is where the leader, the syndicate leader, does have a little role. So at about 5 minutes to go, we'll just wrap you up, and we will ask each of the team leaders just to give literally a 1 minute statement on what your three information technology priorities, ideas, concepts are going forward. Don't need to kind of say why. We just want to hear from each table. Okay. All right. Let's go to it. Thanks. Folks, if you've, hopefully you should have something kind of resembling 3 ideas right now, or something kind of close to it. I think I've got reasonable surety that that's the case. We're just after a quick short sharp from the presenters, from the syndicate leaders. So let's start over here and let's go around clockwise. So table 1's ready, very good.
Quickly, we picked up 3 items there. Quantum computing technology. The second was DNA genetic emergent convergence. And the third is a concept, ubiquitous surveillance, where basically you know where everybody is at any one time and what they potentially are doing.
Excellent, thank you.
Table 2, we discussed a number of issues, mostly around the common theme. One of the main issues was autonomous systems, everything from delivery of packages, for example, use of autonomous vehicles, use of autonomous subsurface, surface and to achieve combat effects. We also talked about self-adapting data analytics, i.e. what we're really talking about there is gathering large amounts of data, particularly when it comes to tracking of individuals, using that data for our own purposes. And the last one was the convergence between humans and machines, i.e. humans being able to understand machines better and machines being able to understand humans, and what opportunities what that brings.
Great, thank you.
Hi.
Oh. It's counterintuitive. Standing in front of the speaker means you can't be heard.
All right, I was just trying to not have my back to people. Okay, strong AI we thought was our top one, so a human-like cognitive artificial intelligence. And we had population tracking and identity, which closely relates to the one over here, where we can know where everyone is, and we got into some of the health aspects of that as well with monitoring humans. And also the CRISPR technology with gene drive and gene hacking. They were our top 3.
Right, thank you.
Okay, and table 4, our top 3 was quantum computing, so we're looking at processing speed in smaller form factors and able to solve problems that are not currently solvable. Number 2 was artificial life, so talking the ability there for life forms that don't age, don't need food, water or sleep, and able to manufacture them at large numbers at lower cost. And then finally, we had advanced AI, so AI that's truly creative, adaptable, analytical, and able to deal with uncertainty.
Thanks very much.
Okay, Group 5, we had real-time, self-aware, self-configured AI, so much like Group 4's approach. We also had the realisation of that exaflop 10-watt hardware that'll support that sort of thing. And then the last one, and Mal Tuddy takes full credit for the very poor pun here, is that cyber trumps kinetic. So that's the idea of a cyber effect being used in preference to a kinetic effect.
Okay, good. Number 6.
Okay, table 6. The 3 we had out of the 20-year mark was bio, brain and hybrid. So bio was trusted, unbreakable identity that could be used in a ubiquitous form. The brain was connecting the brain, so this is about harnessing the cognitive on a really large scale. And the third one was with hybrid, it was the hyper-augmented angle that could be exploited.
Mm-hmm. Good.
Okay, so our first of 3 was developing the technical measures for trust in autonomous systems. What does it actually mean to say that you trust an autonomous system in the technical sense? The development of particular technical standards to make that happen, which are widely accepted throughout the community from scientific, technical and standards organisations. The second one was similar to that, except it was trust by society at a social level for what it means to trust an autonomous system. And we're particularly thinking here about the fact that in the time scales in question, most of us will be retired and half of us will be flat in our graves. And the country and industry will be led by people who have much more digital skills than we have and are far more likely to trust autonomous systems than we do, and far more likely to accept that those technical measures that I mentioned in our first idea actually mean something in practice. When these people have control of the political life of society and the social life of society, I think that will come. And the third one was secure, distributed, networked smart sensors. We think that there's the potential for these to be ubiquitous in the cities and the countries of the future, and the changes that will bring will be absolutely phenomenal when they're all networked back into central databases. Now, clearly, that relates closely to the Internet of Things, but I guess, we prefer to think of it in terms of smart distributed sensors. Thank you.
Good, thank you.
All right, so our first one was digital identity authentication. That is, what are the implications when you can no longer be anonymous on the internet? Our second one was embedded brain-computer interface, so what the implications are when you're actually able to connect probably wirelessly to the internet directly via your brain, download apps, data, visualizations, maybe increase your IQ points. For anyone who's interested in exploring that concept further, the recent Ghost in the Shell movie is well worth checking out. And finally, we also talked about this concept of having humanoid robots. So not just robots that look human, but robots that are teachable and that are able to basically take over most roles that humans could do.
Thank you. Number 9.
The three areas that we had, the first one looked at Internet of Things, and networking, really focusing on things around health and language translation, think Star Trek. The second one focused a fair bit around autonomy and AI, so obviously autonomous vehicles, robotic cops, natural language conversation. The final thing that we looked at was really what we thought was underlying all this, and we'll put it as cool physics, engineering, and infrastructure. And somebody else talked a bit about models, but without the smart computing, the quantum computing, the advances that we're making there, then we don't think that the other things are achievable.
Thanks, Liz. Nigel.
So we started off with information fusion, and that is making sense of the data. We've got all this data out there. How do we put it all together and do something with it? We then led into the computing collaboration, how we can synthesize it together, possibly called cognitive computing. Leading out to that is the optimised of the IoT, and that is what are the devices that are going to talk to each other, how are they going to talk to each other, what's it all going to mean, and what are the emergent applications that will come out of that to make life better.
Great, thank you very much. We will just hold those now and we'll move on to the second session. But don't worry, all those thought babies will return later on in the day, and we'll explore them further. So thanks very much for your participation so far, and we'll crack on with... Invite the speakers up for session 2, please.
Good afternoon and welcome to session 2. Bit cut down compared to this morning's session, but of equal importance as we move on to the next phase of the symposium. So you've probably already worked out our cunning plan, and that is to have some speakers introduce some thought-provoking ideas, and then we'll lead into a workshop activity. And we'll be doing that after this session as well. This session, titled Big Ideas for a Hyper-Connected Megacity, is certainly where we're interested in moving forward, and CDS asked some questions this morning about, well, what happens in these megacities. Should disruption occur, for example? So four speakers this morning, and let me introduce the first speaker, Professor Chin-Teng Lin. So CT is currently the Chair Professor of Faculty of Engineering and Information Technology at UTS. He's also a Chair Professor in Computational Engineering at NCTU and the International Faculty of University of California at San Diego, and an honorary professorship at the University of Nottingham. So Professor Lin is well published in the area of neural networks, fuzzy systems, multimedia hardware, software, and cognitive neuroengineering, and has a large number of publications. So CT.
Thank you. Yeah, good afternoon, everyone. It's my great pleasure to present you the applications of brain-computer interface, BCI. So in the data science, people talk about from the data to information, to knowledge, and to intelligence. And since the main theme of this symposium is the digital disruption, so we will consider big data, social media, cognition, and quantum and machine intelligence. So, we will consider the social, human, and machine integration systems. We can call it a cyber brain. So in the future, the cyber brain system, we will consider not only the physical state of machine, we also have to consider the human or cognitive state and also the environment states. Nowadays, we already have a lot of technologies to help us to understand the physical state and environmental states. And the BCI technologies is to help us to understand the real-time human cognitive states. So BCI is to study the brain and behavior at work. The goal is to augment human performance such that we can enhance mind, body in health and well-being. There are two categories of core technologies for BCI. On the hardware part, we are looking for the wearable devices, or even in the future might be the embedded invasive devices. Just that we can detect the brainwave and other physiological signals in daily life activities. On the software part, we can use AI technology, such as machine learning, to help us to understand what's the meanings of the detected brainwave or physiological signals. So for example, for hardware, we can have the devices like the wireless wearable EEG sensing devices. For example, we need to develop a so-called dry sensor, such that we can measure the brain signal easily without using the conductive gel, and also we can design different kind of the EEG head with the different density, number of channels. And also we can integrate a brain, the EEG handset with the Keynote, with eye tracking, with the lip motion, such that we can measure the cognitive state, machine state, as well as the environmental state simultaneously in real time. And also we can integrate the dry sensor and the EEG sensing devices into an AR goggle or VR goggle, for example, for the training purposes. For the software, for example, we should develop the EEG signal processing and machine learning technique such that we can understand the brain dynamics to assess the cognitive state based on the major EEG brainwave signal or physiological signals. There are two major applications of BCI. One is for the normal person for daily life application to augment human performance. The second is for the patient, especially for the chronic diseases patients for clinical application, such as sleep disorder, depression, and migraine. So I think the brain will play a key part in the Internet of Things systems, such that the brain-computer interface technology were important technologies for the future intelligent Internet of Things. The BCI technology can be applied in 24 hours daily activities. For example, we can use the BCI technology for brain training based on the kind of education, material design, or even the gaming. Also, BCI technology can help us to detect the fatigueness and also provide the feedback to wake up the driver or the machine operator, for example. And this video shows that during the driving, and the EEG signal can be detected and widely And also, we combine the BCI technology with the VR or AR goggle used for the internet shopping. This is the hot area in the future for neural marketing application. And also, BCI can be used for environmental control, especially for disabled persons. For example, the EEG can use the brainwave to control a robot for the feeding assistance or other kind of the environmental control. And also, BCI can be used for the sleep quality assessment and also enhancement through some feedback mechanism, such as the aroma therapies of the light or music control. And BCI has also a lot of applications on the clinical, especially for the chronic diseases, such as sleep, migraine, depression. For example, we can design a migraine hunter that using the BCI technologies to design a personalized biofeedback system for pain relief. So based on the detect EEG signal and also the environmental signals, the AI system can help to predict the onset of headache for migraine patients and also to provide a personalized treatment recipe. Also, excuse me, the BCI has also a lot of applications in defense, especially when we consider in human factor, such as human behavior, human capability enhancement, and human system integrations. I show you two examples. One is for the BCI-based soldier resilience training. So we can combine, as I showed you just now, we can combine the BCI technology with the AR goggle or VR goggle for training purposes, such that so the soldier can wear AR headset and brain imaging devices, armband, wristband, and just can training in a virtual reality or augmented reality environment. For example, with the AR goggle, combined with the BCI technology can be used for the dual task training, including search and engagement. So the primary task might be the threat engagement shooting task, and the secondary task can be the navigations. It's just that we can use the BCI technology can detect the cognitive state and performance of the soldier and to change, to adapt the content of the training material. The second example is we can human machine autonomous systems for the situation awareness. So we can combine the human intelligence and machine intelligence to develop a high efficient and reliable human machine autonomous systems. So this example shows that for the pilot, the BCI technology can detect the the eye movement, brainwave, and behavior, and to assess the workload and the fatigue of the pilot. And also we have machine intelligence to help. It's just that we can understand the current attention window of the subject. So for example, if the pilot is in high workload and high fatigue, and such that the attention window becomes smaller, in that case, the machine intelligence can detect maybe the target which is outside the attention window of the pilot, and such that he can bring the target inside, within the attention window of the pilot, such that to improve the safety of the pilots. So this is just some thought for your consideration. Thank you very much.
Thanks, CT. I like that sleep-enhancing element. I think it needs to be more research there. But anyway, I'd like to introduce our next speaker, Professor Philip Leong. He's going to talk to us this afternoon on real-time machine learning. And Professor Leong is a professor of computer systems in the School of Electrical and Electronic Information at the University of Sydney, and has worked in field programmable logic and technologies for quite some time, and is certainly well published. So, Professor Leong.
Thank you very much. Actually, the 10-second version of my talk is that we should just do what Professor Lin suggested on a single chip at 10 watts, all the processing. So that's the, that's the high-level view. So actually, maybe what I'm talking about, it's relevant to a megacity, but maybe even more relevant to capability concepts. So who's heard of the OODA loop here? Yeah, okay, most of you. So I can't really do it justice in 1 minute, but it's an explicit process used to thrive in an ambiguous environment. And the important components here are that what you want to do is that you want to make very careful observations about the unfolding situation, and also have plans already in place. And you synthesize these observations in the orient and decide steps in order to try to achieve your goal in a way which is more agile, faster than your opponent. So an example is if you're playing basketball, what you might do, well, what you shouldn't do is just head towards the basket and try to, score a goal. What you want to do is maybe do a dummy move, make the opponent commit to defending against that. You've already predicted they will do that, and then you go around them and score the goal. So this idea, although it was for military strategy, has been applied to business and life. So that's one idea. Another idea, a different idea at this point, is that machine learning has got really good in the last 5 years or so. So things like computer vision systems can achieve accuracies very similar to humans, sometimes surpassing them. Speech recognition is almost as good as humans. We can do machine translation, recommender systems. All these are kind of low-level, tasks that all humans can do. Now, going from the lower-level task to the more strategic tasks, the IBM Watson beat the best Jeopardy players. Now, if you're familiar with the game of Jeopardy, the questions are very complicated natural language processing problems. And they've got puns, and you have to be able to decipher the question and then retrieve this information. Also, in the strategy game, the hardest strategy game is actually Go. But recently, computers have been able to exceed even the best Go players. So we already use things like the OODA loop in Internet of Things applications. So what we can do, a typical Internet of Things application would have some kind of sensor. It would then make these observations and send the data up to the cloud. The cloud would be analyzed using these types of algorithms. Some decision will be made, and then this being used to control the process. Okay, that's great. We can do that today. The thing that we don't have is we can't do this with really low latency. And by low latency, you know, in the 100 nanosecond type range. And what I'm advocating is to develop the capability to do this, to be world leaders in this area. And the way I envisage we could do it is with a single embedded device, which is a chip that can integrate, you know, all these different types of machine learning techniques, along with the sensing and the control and everything in a single chip. And this chip should be energy efficient, so it could be powered from batteries and made really small. It should be parallel so that we can actually execute, you know, something like this Jeopardy thing in 100 nanoseconds. It needs to be integrated. It's got to be a single chip. It can't be, you know, a refrigerator-sized device. And it should be customizable so that our investment could be applied to many different applications. So would such a chip be really expensive to develop? Well, actually, no. These chips exist. These are called field programmable gate arrays. You can buy them off the shelf. And a modern field programmable gate array is a system on chip. It has, whoops, now I've messed it up. I can go. It incorporates ARM processors, 64-bit ones with dual core or quad core. This year, we will have FPGAs which can do sampling at 4 gigasamples a second and digital to analog converters at 6 gigasamples a second. There's FPGA Fabric, which is like logic, which you can implement these complicated machine algorithms, learning algorithms in parallel with. And they have interfaces to anything you can imagine, to the networks. They have memories, of course. Interface to networks, other chips. They're relatively low power. And we have really good local industry. For example, Ian Heddle there from Exablaze, they developed the world's lowest latency network switches, which are used in trading applications. And these devices can be reprogrammed to have different functionality and to also upgrade the algorithms as they're developed. So on the same FPGA, we could be at one time doing voice recognition and then at a different time doing face recognition. So the applications of this device, all the ones that Professor Lin mentioned, plus also, prognostics. You could use this to, say, monitor systems on the smart grid, and if it were fast enough, you could get around this problem of latency and you could perhaps prevent blackouts due to cascading faults because you've got this really low latency decision-making logic. You could do ubiquitous sensing and surveillance, as was mentioned before. You could make intelligent traffic lights, which are very, modest type application, all the way to, being able to look for certain types of patterns in video data. You could use this to understand radar, sonar, hyperspectral image data, and make things that react in machine times, not human times. You could improve situational awareness in robots. For example, autonomous drones that conduct entire missions rather than not being very intelligent. And we're actually working with Phil Stimson's group on cybersecurity and electronic warfare, where we're looking at radio frequency signals and trying to do anomaly detection and information understanding at network speeds. So, for example, respond to jamming. So this may sound very far-fetched, but we've been working towards these problems. So we've developed the world's lowest latency simultaneous learning and prediction engines, which for time series can do simultaneous learning and prediction at 100 nanoseconds and with latency, and at throughputs of 70 gigabits per second, which is about as fast as you can send data to a chip. Recently, we've published work which is this convolutional neural networks, which are really good for image processing, image classification. We demonstrated on an FPGA which dissipates 25 watts, 12 million classifications per second with 0.31 microseconds latency, achieving 96% accuracy on the MNIST benchmark. So to summarize, there is these new technologies. Machine learning advances have allowed the orient and decide parts of the OODA loop to be done with performance better than humans. And FPGAs actually allow these to be implemented with unprecedented speed. So the idea that I want to present is create a capability of combining the two and develop the different types of machine learning and implementations needed to make such an epic chip. I believe this is certainly emerging in disruptive technology with widespread applications. Everybody is investing in large-scale machine learning. I suggest that what defense does is look rather at low-latency machine learning and the integration of it into a single chip. Thank you very much.
Thank you. So the first two speakers really spoke to us about how we're going to interface with data and potential opportunities, which are really very exciting. The next two speakers are definitely down the line of smart cities and how we might be living in those spaces in the future. So allow me to introduce our next speaker. Mrs. Sarah Stace is known as a strategic thinker and a consensus broker with extensive knowledge about cities and urban transport. She is particularly interested in autonomous vehicles and emerging technologies that will change the planning and design of our cities. So welcome Sarah with me to speak on Smart Cities Initiative.
Thanks. This is going to be on quite a different wavelength to our previous couple of speakers, but hopefully it makes some sense. So I'm formerly in the Australian Government's Infrastructure Australia, and I now work as a consultant to state and local governments on cities and transport policy. Oh, I'm just going to have to work out how to use this clicker. In this session, I'm going to talk about this topic we've got of mega cities and the fact that we need to reiterate why cities matter. Well, they matter because 75% of our population lives in a major city and 80% of our GDP is generated through cities. So they're highly productive and it's where people want to live. But there are some complex, I'll call them wicked problems in our cities which technology is unlikely to resolve of its own accord. So for example, housing affordability issues, entrenched disadvantage, combined with a change to our dependency ratio, which means that our proportion of working age population compared to non-working age population is changing. This leads to reduced economic prosperity and disenfranchised population, which is clearly an underlying security issue potential. There is a lot about the future that we don't know, but there are some certainties, for example, population growth and demographic change. The Australian Bureau of Statistics predicts that we'll have a population increase of about 8 million people over the next 20 years, which is equivalent to 3 million additional homes to be built. And it's sort of roughly 18 Canberra's worth of additional population to today. That is extremely massive change to our society and population. And it's about 1.2 additional Sydneys. This is a massive scale in the next 20 years. When we look at, oh, it's not a bit blurry, but anyway, when we look at what that means in specific cities, this is Melbourne and Sydney at the same scale. The population of Melbourne, 4.3 million in the year 2013, will be about just over 6 million by 2031. And Sydney and Melbourne are going to equalise in size. Perth and Brisbane are both predicted to equalise at around about 2 million people at that point. So we're starting to see a jostling of position on which city has the primacy of size. On this map, each dot represents 50 people. By 2060, there'll be double that many dots on these maps. So you can see that density, space efficiency, land use planning are all essential. And technology can solve some of these issues. For example, we could put in high-speed rail to connect our cities. We could have better telecommunications that might reduce our travel demand, but essentially those issues will still be there and probably increasing in intensity. This is a series of photographs that shows how inefficient our current car system is. Each photograph shows 70 people being moved. On the left, we've got 70 people being moved by bus. We have 70 people moved by bicycle, on foot, and 70 people being moved in cars. We average about 1.2 people per car in Australia for our general travel. So this is a problem where we're trying to increase the density and efficiency of our infrastructure systems. Earlier today we heard from Professors Hugh Bradlow and Ian Reid. Both of them mentioned autonomous vehicles. I'm going to talk, I won't sort of look at this drone delivery and freight trucks and so on. I'm going to look specifically at robot taxis and private cars, this cute little thing here. And some of the issues that would need to be resolved in terms of regulation and pricing, issues around private versus public ownership and usage, and efficiency. So, broadly speaking, I like to think of these these individual cars at two ends of the spectrum. At one end, you've got a 100% privately owned system, and at the other end of the spectrum, you've got a 100% shared system. I'm going to call it Carmageddon and Autopia. I'm going to give you consider this. Autonomous vehicles are going to be extremely safe. Many of the safety features that we currently have built into our cars will essentially become redundant. So seatbelts, for example, perhaps we don't need to be wearing seatbelts. Perhaps we'll be cushioned by airbags if there is going to be an impact. So they'll also be much smaller. You may end up with one-person pods. We don't need to have vehicles that hold 4 people or 5 people in them on average. I predict that we'll get to a point where they'll be so cheap it might only cost a couple of $1,000s to buy a car. So there's no reason why every person in the household can't have their own car. I'll give you an example. Jane, age 9, is dropped at school by her driverless car pod. After school, she scans her phone at the school gate and her car pod comes and picks her up, takes her to soccer training, and then is home by 5 p.m. How convenient. You're at work, it starts raining, you call your car from home to come and pick you up. The problem is that these cars are now travelling half of their time empty. So in this scenario, you've got a lot of cars that are essentially you're starting to increase the vehicle fleet. It's pretty alarming, actually. In this scenario, incidental exercise disappears. Walking to the shops, the bus stop, school, no longer is something that you need to do at all. Traffic congestion increases. In the long term, it doesn't solve any of those wicked problems that I mentioned earlier. Today, just right now, our current cost to public health of sedentary lifestyles, so diabetes, cardiovascular disease and so on, costs us $130 billion for direct and indirect costs. And I don't think that driverless vehicles are going to solve that problem. So coming back to this spectrum issue, if we instead had 100% shared vehicles, so the robot taxi scenario, we in fact reduce the number of vehicles on the road overall because each vehicle is used by multiple people many times a day. The research on this shows that it's actually essential for our environmental, health, social and economic security. But it will take a number of mechanisms to achieve this. It's not going to be solved by the free market of its own accord. We need to have long-term policies that steer us in the right direction. We need to have road user charging, especially charging for the empty vehicle miles and private vehicle ownership. And we need regulation. I think we've discussed earlier the issue, the education of regulators. It's clearly an issue across a number of different areas. So to reiterate, 3/4 of our population lives in cities, and these cities are growing rapidly. In order to ensure that our quality of life, health and economic prosperity is maintained, we need to address these complex and deep-seated issues. Technological advances can help us to achieve these if we have the political willpower, quality evidence and long-term policies to do so. Thank you.
Thank you. And let me get to the right part of my sheet here, to our last speaker of the day, who will talk to us about adapting the current for future information needs. It's going to be fascinating. Can I invite Mr. Darren Crombie to give that presentation? Darren has 20 years experience in the infrastructure planning and aviation innovation sectors, overseeing a range of strategic planning, policy and program initiatives, both from the state and federal government perspectives. Mr. Crombie was previously a Deputy Director General and Strategic Advisor for the Department of Science, Information Technology and Innovation. He has previously held senior executive roles in the infrastructure and economic development portfolios in the Queensland Government and in the transport and infrastructure portfolios in the Australian Government. Darren.
I'm going to predict I'm not going to stick to 10 minutes, but we'll give it a go. See how we go. All right. I wanted to sort of give you a bit of a sense of the world I inhabit. So my role is very much about taking the infrastructure that we have today and finding new and clever ways of using that and trying to work out what the infrastructure is that our cities and communities need going forward. From the outset, I'd say that we don't do infrastructure just for the sake of doing infrastructure. You do it for two things. One, to actually make human lives more livable, and two, to get products from product place to market. So how does the farmer get beef to the market? So for us, we look at it through both a livability and productivity lens. This is some work we did in Queensland. So a lot of what I talk about is based around the Queensland experience, but it's not that different to what's happening in the other major cities. So we live in an urban complex in Brisbane, which goes from coast to coast, and it's very, very low density for a big part of it. So we have a lot of challenges getting people moving around and planning for that growth. So we're looking at a population of around 7 million, thereabouts, by 2040 between coast to coast. So we're getting up to the sort of size that the Greater Sydney area's got in the next 20-odd years, but not the kind of density that Sydney and Melbourne are going to have. One of the things that we do is have a good look at what we've got today. Now, this is some work we did for the State Infrastructure Plan recently. And what we tried to do was show what's the demand that our communities have for all those essential services. So what does your mum use? I asked this question. How much time does my mum spend in a hospital, on the road, in prison, using the electricity? How much water? And that was a really tough challenge to answer because we actually don't know. And it varies from state to state and place to place. So we know, for example, in South East Queensland, we use a lot less power and water than people in the far north Queensland do, on average about half. So how does that then help us to indicate what do we need in the future? Now, what's interesting for us here, we actually ran the projections around what we've got today with what we'd need out in 2036. And with the exception, everything is going up considerably. This one I got no idea about. Like, seriously, we just took a wild guess at what the digital use would be in the next 20 years. 5 years ago when I did this exercise, we didn't even look at digital as an infrastructure means. That's how fast the world's changing. The interesting one for me is already, on our current projections, energy use is going down. For me, it's the actual infrastructure class at the moment where technology is already starting to change what we do and how we do it. What I'm interested to see is how it actually starts to impact on the use of all that other infrastructure we've got. We also know that our existing system is pretty good. We know that in Queensland we've got, the accountants tell me it's about 300 billion worth of assets. We think replacement value is closer to $1 trillion. So that's Queensland. IA, Infrastructure Australia, tells us that about 85% of the infrastructure that as a country we need by 2036 already exists today. So the challenge is not how do we actually get more and more and more. In my mind, the challenge is actually about how do we use what we've got today in a much more efficient way. And that's in particular where the technology question comes to the fore. Look, my eyesight's shot, so I'm guessing you can't read that either. But in a simple way, what this is saying is that from our perspective, there's an increasing order of preference when you actually make decisions about what to do in terms of building new infrastructure. You actually start with trying to use what you've got. So how do you actually bring in, for example, things like road user pricing to actually get people using the roads in a more efficient way? Road pricing is an interesting one, incredibly politically challenging. No government really, I think, is going to take a serious crack at that this side of 10 years because it's just politically too hard. So if we can't do road pricing, what else can we do? We can start to use the existing infrastructure we've got much more effectively. So that's about getting multiple people in the one car, carpooling, for example. The next one is actually about improving existing. So this is where you get things like what they call intelligent transport systems. So the big signboards that tell you to slow down, speed up, whatever it is. It might be adding a lane to a motorway. The last option is to actually build new. And this is where I think the technology and disruption is actually really fundamental to the way our cities work. Because for my mind, most of our actual investment going forward is going to be in this space. All governments are fiscally constrained. We can't keep building at the rate we've built in the past because it just costs too much. This is where we're actually going to get the big gains that allow our cities to function effectively in the future, in my personal view. Going back to the energy one, for example, disruptions here now. We're seeing what's happening to the electricity systems right now because of the rise of battery, because of the rise of solar PV. So that really then starts to have to say, well, how do we use the existing systems we've got more effectively? And I'm banking on some smart 14-year-old kid in a garage coming up with a solution. One of the things that intrigues me in my job, I range across from asset policy, i.e. how do we use what we've got today, to what do we need in the future. When I have a conversation with agencies about what we need in the future, I get to talk to strategists and people like yourselves often as not really smart folk. When I talk to the asset owners, I usually get to talk to the facilities manager, who's usually totally disconnected from the conversation about what's going to happen in the future. My takeout from being in this game for a while is that in the infrastructure space, there's a whole lot of folk who actually do a fantastic job at constructing assets, designing tunnels, designing systems. There's another bunch of people that I call the technologists, the ICT sector, the digital analysts and all the rest of them. They don't talk to each other very much. And I think that's a real shame. I also think that going forward, that's actually where there's a whole pile of opportunity. Go back to that simple stat, $1 trillion worth of infrastructure, and we've got to work out how to squeeze that lemon to get every last bit of juice out of it. And there's a lot of gains to be made by getting those technologists who look at the world through a completely different lens, looking at traditional problems like how do I use the road network? How do I actually get the sewer systems to work more efficiently? How do I deliver water more efficiently? And that's where I think there's a lot of opportunity. 2056, what's it going to look like? I got no idea. 5 years ago, we didn't even talk about digital when we were talking about infrastructure. Now, today, the conversations are around how do I put a sensor in a sewer pipe, or how do I put a sensor in a stormwater drain so that as soon as it rises too fast, send an SMS, get someone out of a house in a low-lying area. We're doing it now. Do we do it routinely? No, we don't. Do we do it in a smart, sophisticated way? No, we don't. Somebody said to me the other day, why wouldn't we go through all the stock of old health and hospital and education buildings, find all the ones with a bit of asbestos in it, throw a $50 sensor in it and calibrate it to alert me if it's going to vibrate or get too wet. Rather than mothball a multi-billion-dollar asset or a multi-million-dollar asset in a rural town, stick a $50 sensor in it. These are the sort of conversations we're having now. In my mind, that's where we need to keep going into the future. ITS, Intelligent Transport Systems, part of the transport solution. For my money, the really big challenge we've got to address is the rise of the individual, what I'd call personalised choices. Sarah touched on it before, but I think this is probably one of the biggest single issues we have to deal with in complex urban systems. We all have one of these, we all want individualised services. So how do we take, for example, Hugh Bradlow's stock of geo-positioning off these things for every person in a city, and match that with the desire of people to get on a bus out there in about 5 minutes? Massive data stocks, we don't have very many people who are good at fusing that stuff together. And to me, my girls are 9 and 11. I'm telling them, you want to be a rock star in the future, work out how to do that stuff, because that's to me where the real challenges for society lay. Okay, one example of how digital is transforming infrastructure today sits within our energy sector. Somebody said before about Tropical Cyclone Debbie. We had last week that thing ripped through up north, and then it sort of did a big U-ey and then came down the south and hit Brisbane and then northern New South Wales. 170,000 homes without power. In Proserpine, we've still got 45% of the population without power, something like 2 weeks on. We know that climate change events are going to get more severe. These sort of disruptions are not going to get less frequent, they'll become more frequent. If half of those 170,000 homes have PV, and you had a whole pile of cars, electric vehicles with those big batteries, how long is it going to be before we actually start to look at fusing things like the PV systems with the energy in the batteries or the batteries in those cars and actually replicating the grid during times of crisis? We're looking at having something like 3,000 megawatts of electricity in Queensland produced from PV in the not too distant future. We've all talked about the rise of AVs. Well, I reckon the rise of EVs is going to be the one that actually seriously challenges how our energy system works. That's the sort of stuff that's possible now. This kind of distributed, digitally transformed network is happening now. AGL have just recently, AGL in South Australia have just started a trial of this. And I saw a new city outside Tokyo late last year where this is exactly what they're doing today. So this is the sort of thinking that we need to embed into our systems across the country. I told you I wouldn't manage 10, I reckon I'll be done in 12. One of the things that is actually a real challenge for us is the use of BIM, Building Information Modelling. The beauty about this stuff is it actually allows us to take that $1 trillion worth of what I call dumb infrastructure and start to actually weave into it a lot more smarts. Now, the beauty with BIM is it allows me to send a plumber out when a pipe ruptures somewhere, bit of augmented reality, and suddenly you've actually got the capacity to send a tradesperson, who may not be the first person you think of as being an uptaker of technology, out with smart technology, find the pipe, fix the pipe, let the rest of the suburb get on with living. At the moment, this is the sort of stuff that's being applied across some massive projects across the world. Crossrail in the UK, which is a £15 billion project, has been run exclusively using BIM as its basis. They've got 1 million plus CAD files embedded in one system, and the cost estimates of what that is saving that project are in the order of 5 to 10%. That's serious money, simply by using technology for the delivery of traditional infrastructure. Final slide. So, what's all this mean in a hyper-connected city? In my mind, digital, based around our existing stock of infrastructure, allows a number of things to happen. It allows us to get much better use out of that existing stock of assets. All of you have houses which connect to the roads, connect to the electricity grid. You've probably got NBN depending on where you live. But think about all the other dumb stuff that makes life easy. Your sewer pipes, your water pipes, the stuff you don't give a thought to until it breaks. And this is the challenge for me, is that most of that stock of infrastructure we've got now, no matter what happens to the growth of our cities, is still going to be the underlying backbone. So my challenge is, how the heck do you get that dumb infrastructure working in a much smarter way once you've actually got the Internet of Things fully operating? How does that allow you to actually transform the lives of people? We will see, definitely, through the rise of individual choices, real-time, mobile and customised delivery of services. People are going to expect that, and the generation coming through are going to demand it. I think politically, unless people can actually work that out, there's going to be a significant social problem in this country. There's going to be major levels of controllable demand, and that's going to mean that we actually can avoid having to build lots of new kit, but we are going to have to work out how to use what we've got. I'm from Queensland. Cyclones hit. How do we get more resilient? New South Wales, you've got problems with fires, as do the South Australians and the Victorians. Natural disasters are a thing that we have to live with, but we also need to work out how do we use technology to actually help people avoid those situations or manage through them. I see there's a whole pile of new business opportunities. As I said, I'm going to steer my 2 kids towards working into this kind of intersect between infrastructure and digital, because I think it's a fantastic opportunity. Not only is it about new business opportunities, but there's new emerging markets coming. Some of this stuff we haven't even predicted yet. And if I was actually talking to a careers day, I'd be getting kids to think about, somebody put up a slide earlier about all the professions that are going to go. What are the professions that are going to come? We haven't had that conversation yet. And finally, from my mind, all of this is fantastic and interesting, but one of the real challenges is this is going to fundamentally test regulatory systems as we know them. We don't have a clue in a lot of the regards to this stuff about how we're going to manage price structures, market reforms, or the regulatory systems which actually underpin this stuff, and I think that's a huge public policy challenge. And finally, our urban systems have built up over 150 odd years. The fundamentals are all pretty much in place. The grids are in place, the networks are in place. We talk about a changing world. Right now, we don't know how one of these things is going to change how we work, where we work, or when we work, or what kind of work we will do. So one of the really interesting challenges for me, for people to think about, is how do we actually take a very different nature of the way we react to technology, but still live in an urban fabric that's actually been built on 150 years of industrial revolution? What's the digital revolution going to mean to the way we work and where we work? And that'll do for me. Thanks.
So thank you to all our speakers for this session, certainly diverse and thought-provoking for me. We've got, I think it's the first, we're actually ahead of time, but so we've got plenty of time for questions and discussion. Peter.
Peter Nicholson from the Institute for Regional Security. I'll go straight to the very last phrase that you used, Darren. I want to talk about the cities. There's a real paradox. On the one hand, we have all this dumb infrastructure, as you call it, that makes, if we can make it work better, can handle more people. But on the other hand, we have something going on which we're calling some sort of digital revolution or disruption, in fact, today, which means that we know that in something like 7 or 8 years, 40% of existing jobs won't exist. Why have we got such big cities? It looks like we're going to have the capability to actually work in a quite different way, in quite different places. Why should megacities even come about?
I was looking for the on switch. Again, I'm the Luddite in the room. Look, at the ultimately, I think it's actually about personal choice. People will make a decision on where they choose to live. I live in the state of Queensland, where we are actually the most decentralised state in Australia. So while we talk about megacities, for my mind, we also talk about a range of regional cities spread out around the country. People will not make a choice where they live. I mean, people tend to actually agglomerate in the major cities for work, but as we age, people, I think, are going to actually continue to drift towards the major cities for health services, higher education opportunities and the like. So, you know, there's no good reason why you can't live in a perfectly digitally connected world in a regional centre like Townsville. Would any government want to sort of force the issue around decentralisation? I don't think so. We tried that pretty unsuccessfully in the 70s. So, you know, I think ultimately it's going to come down to where people can actually find a job, where they feel they can get the best access to services. And the wildcard in all this, I think, is going to be changing demographic and migration patterns. So what we do see, for example, is that certain cities tend to actually have people who are much more accepting of density, and in part that depends on where they've come from. You know, we see much higher levels of density in Sydney, for example, primarily driven by the patterns of migration from overseas, than we do in Queensland or in Adelaide or Perth. So ultimately, I suppose, we're each creatures and we make decisions about where we choose to live. And I don't think I've answered your question.
Yes, I agree with what you've said, Darren. And to give a specific example, I worked a number of years ago in Perth as General Manager of a listed property fund. And one of the issues we found was that we needed to talk to other property fund managers, and they were all located in Melbourne and Sydney. So we had this tyranny of distance of 3 hours time difference plus a 5-hour flight, etc. And so in the end, the managing director moved from Perth to Melbourne. Where did he want to locate the office? In Collins Street in Melbourne. There's no particular reason why that should be the case in a digital age, but the fact is that businesses do like to stick together. People do like to have that face-to-face interaction together, and I think it's going to be a long time until that fundamental changes.
Now, do you have any other next question? David?
David Miller again for Professor Chin-Ting. Do you have any concern about brain-computer interfaces, about risks associated with that? I'm just thinking it's been 1860 since we had a really decent EMP on planet Earth from space weather or sun weather. I could imagine if you've got a dependency on these devices or overstimulation of these devices, you could actually cause quite a great deal of harm to human brain or nervous system. Not just EMP, high frequency magnetic radiation, but all of these things are then causing damage to the host. Is that a concern?
Yeah, I totally agree with you. The concern about the developing of a brain-computer interface related technologies about since the sensing devices are so close to human, and so I believe there is still a lot of ethic issues we have to work together, and I believe this is interdisciplinary research. We need experts from different areas to work together, but at the same time, from the technology point of view, I think this is also an important research area. Actually, people currently talk a lot about sustainable computing. It means that when we developing computing technology, we have to consider about the sustainabilities from every angle, every aspect, from the natural resources, from the power, and also, of course, from the human, and also from the job, the society point of view. Similar to the sustainable computing, we should talk about the sustainable AI, artificial intelligence. This is also important. So, for example, in the morning section, many people worry about the job problem with the robot or artificial intelligence replace many job opportunity, and this is also one factor we have to consider when we develop AI technologies. We should pursue the sustainabilities from different angles. Thank you.
Andrew Belmax from Noetic. Very interested about, well, two questions actually about the concept of a megacity. Whilst there's lots of opportunity, our infrastructure in many ways will also limit some of those opportunities, and I'd be very interested on your thoughts about that. And the example I give is some of the automated systems on the ports now. If you were actually optimising the infrastructure for those ports, you wouldn't build them the way that they're built now. And so as a result, the machinery actually has to put in a variation because it's just wearing out tracks in the concrete because it moves fundamentally along a particular path. So just wondering on your thoughts about how we might optimise the opportunity to take advantage into the future, and indeed what your thoughts are about the limitations of our ability to optimise what's possible in the future by infrastructure. And the second one is linked to that. Do we, if we are hyper-connected, do we actually have to have a megacity? Or might we actually be able to distribute our city infrastructure much more broadly rather than have this massive conglomeration, Sarah, that you identified?
Thanks, Andrew. So look, the question around the ability to optimise and get around limitations, the physical limitations of infrastructure is an interesting one. Look, ultimately there's going to be a point where something was built for a specific purpose. So without sort of a very significant, physical rebuild, you're kind of stuck with what you're stuck with. I think though that we don't really have a very good handle yet on just how much we can stress a piece of infrastructure before it actually does break and become unviable. Just pick up the example of a port, for example, and whilst you talk about, the physical limitation of moving container, whatever you call those dolly things that run up and down, I saw some work actually by Data 61 or NGTF prior to them becoming part of Data 61, which showed that by actually using some really smart technology, you could actually spread the load of how you use that port infrastructure, and Botany was the one in point. By actually changing the way the trains actually came in and out of the port. And what they actually did was get a much better functioning supply and logistics chain by actually looking at the rail system movements rather than the container movements. So it actually got a much bigger increase out of the productivity of that port by simply changing the scheduling, timing, and then stabling of trains of all things that were to be stacked with containers. So I think, you know, again, it's getting a bunch of, I think, smart folk to look at problems in a different way. The other thing I would say is that in all of this, one of my hobby horses is actually being really, really clear about what the problem is, because we tend to jump to thinking we know what the solution's going to be before we've actually clearly defined what the problem is. So is the problem, for example, in a port actually the capacity of the crane to move it, or is it actually the capacity of the rail system to get the containers out? And where I think there's a lot of fertile ground is for people to actually do a lot of work on actually clearly defining problems, because the solution might actually come from somewhere left field, from somebody who hasn't even been in part of the conversation to date. And I think we see that quite a lot, whether it be ports, whether it be rail. You know, there's lots of examples where we've optimised systems by actually getting smart data analytics people to look at how you actually use that expensive kit in a very different way. The Hunter Valley Rail Coordinator is an example of that. There's been all sorts of work done by NGTF about how do you actually deal with failure of some of the big dams in Sydney, getting people out in an optimised way to avoid all sorts of problems. So this is the sort of, if you go back to my Venn diagram, it's that intersect in the middle of opportunities where I think there's an awful lot of work to be done. But there is ultimately going to be a point at which your infrastructure can only do what it was originally designed to do, but there's lots and lots of ways you can optimise the use of that for an extended period of time. And Sarah's going to have a crack at the second part of your question.
Thanks, Darren. So coming back to that question you asked, Andrew, about the distribution, you know, should we have more distributed cities or more agglomerated cities? Why would we have mega cities? Australia, apart from Queensland, I take the fact that Queensland is more distributed in its cities, but we're fairly unlike, say, North America, which has got smaller cities that are more distributed across the landscape. I think that if I were to put just a purely economist's hat on, perhaps, cities are, as I said, the most productive, in that 75% of our population lives in one of the major cities and 80% of our GDP is generated through cities. So there's more jobs there, we have more efficient use of infrastructure if we're located in tight-knit cities and so on. From a livability perspective, it's where people actually want to go. We don't force people to go and live in a particular location, but they like to. And that's proven, for example, with our 457 visas. Most people on a 457 visa come and live in inner Sydney or inner Melbourne, given that choice of where they want to go. But there's also some inefficiencies, for example, as you approach larger and larger cities, people are pushed further to the edges, they can't afford the housing and so on. So there's that, it's a complex mix, I'd say. But I can't, certainly the trends are that we'll increase to more mega cities than less, and perhaps that's where something like high-speed rail should come into the equation.
Of course, Deputy Prime Minister and Agriculture Department has a various view on where public servants should be living, right? Could I just ask a question to Philip, just about machine learning, because clearly underlying smart algorithms are critical for how we're going to work in the future, and you proposed a potential framework. But Data 61, NGTF was mentioned earlier, and I know Hugh Darrant-White often talks about small data. Often we haven't got enough and we're making decisions on insufficient information, and also learning quickly, so you don't have the large data set. So I'm just wondering if you could reflect on some comments on that problem around fast learning with small data. Is that really achievable, or
Okay, well, I mean, there's the challenge in how you develop the algorithms and how you deal with, not having enough data to actually train the networks and things like that. My feeling is that they're going to, the technology will mature and we will be able to solve more and more problems just by looking at the research overseas and our own research, in Australia. I don't think that I think that will come. But I think that, if there's a sweet spot to actually put some funds in and develop new capability, what I'm trying to argue is that that would be in the low latency implementation of existing techniques, and you know, the investment in that is very focused and would be significantly less than trying to solve a much more difficult and general problem.
Great. Fabulous. Thank you. We have, yes, Sunil.
Sunil Randhawa, DST. Just a follow-up question, Professor Leong, on some of the tension between low latency decision-making, distributed decision-making, and macro instability, like control theory problems. If you have very low latency decision makers, how do you control macro scale stability in your system?
Yeah, that's another, you know, area for research. So I guess what I'm saying is that we need to develop the capability, and we can develop this new tool, which is, you know, taking research that we already have and then thinking about it in ways to optimize the hardware implementations. And then once we have that, we'll have the low latency. How do we actually use it in a control system and all that? That's another research question. But I would see that as part of building the capability up, you know, for us to do our own original research in that area as well. Yeah.
Sir.
G'day, Tom Steen from DST Group. Quick question regarding telepresencing, the concept of a virtual office, virtual businesses, being able to be at home but be at work. Is this being considered as a strategy for a megacity as a means of reducing congestion, traffic and the like?
If you want to have a go at it.
I'm just trying to sort of make sure I'm actually answering your question, but we have to look at various levels of travel demand management. It's all very well doing travel supply, like providing more trains or wider roads or more vehicles, but there are also a number of means available to us to reduce travel demand, and particularly at peak demand. For example, you might have more flexible work hours, you might have staggered school starting hours, you might have more telecommuting, so people don't actually have to do that travel in the first place. So there's a lot of means available to do that travel demand management, because otherwise we try and build our systems to their peak. An example is energy, for example. Should we be building our I'm not an energy expert, but sort of base power to provide for that peak, or should we try and spread the load? It's exactly the same with transport, I think.
I actually think that a lot of it comes down to an IR problem. And I suspect that there's no good reason why work practices can't change other than this fundamental human desire for a boss to have eyeballs on their staff. You know, we've trialled smart working hubs in Queensland to try and actually ease the burden for people who, for example, might live on the Gold Coast and work in the city. We ran a trial that was completely and utterly oversubscribed. So we had the Public Service Commission in that case actually work with us and green light it, so that bosses couldn't actually find a way of saying no to it. And you know, you see a lot of particularly private sector companies, I think they actually do much better than public sector in this regard. And you know, with technology being the way it is, and there is, in my view, no good reason why we can't be doing it. Is it a deliberate strategy as part of megacities? I don't know. Should it be? Yeah, absolutely it should be. But I do think it's going to fundamentally come down to the human factor of, you know, a lack of trust between employer and employee. That's where I think the root problem lies.
And we are streaming out via YouTube, and we do have a question that came back through Twitter, which I think is for you, Sarah. And the first statement, and that is cultural concerns with autonomous systems tend to trust, right, is the key issue, holding back several autonomy programs. So tech moves faster than culture, and so just your reflections on society's adoption, I guess, on autonomous solutions.
So currently vehicles kill about 1,300 people a year in Australia. Drivers kill 1,300 people a year. Will we accept a driverless vehicle killing a single person a year? So at what point will we accept this change of adoption of technology to take that risk. So that once we change over to it, we will go through a very high level of teething period where on the roads we'll have partly driverless vehicles and we'll have driver vehicles. That's going to be seriously problematic, I think. But once we do move to a fully driverless vehicle, it's going to fundamentally change our insurance, for example. Why would you insure a vehicle that's never going to have an accident? So there's a lot of things that will have to change fundamentally within our society, and I think that we'll also go through a period where people are extremely uncertain and mistrustful of what that means, let alone the data and privacy issues as well.
To be in control. Do we have any other questions here? Yeah?
Hi, it's Rohan Samarawira from Department of Immigration and Border Protection, and I have another urbanisation question, sorry. So over the years there has been talk about the government's building another megacity in the north, and my question to you two, particularly one of you being from Queensland, is what would it actually take to build a new Sydney, Melbourne or Brisbane or Perth in another part of Australia, given that we are going to have so many people coming through. We are seeing a lot of disruption with regards to the digital economy, and that some of the old traditional jobs, which used to be the reason why you set up a shop in a particular location, that is sort of going away. What's actually stopping us from building another mega city somewhere else in Australia?
I don't think there's anything in particular stopping us. I'm just not sure that we've had any rational, high-level debate about it. I'm happy to stand corrected, but certainly, for example, in Western Australia, that's an issue that the West Australian government's looked at. Should they turn, say, Karratha into a much bigger city because it's, there's a lot of mining there, there's a lot of money and wealth going through there? Should that be built? There's some issues around climate, etc. But I think theoretically, there's no reason why you couldn't do that. It's just how do you attract people? How do you start that off? Is this a whole new Abu Dhabi? And so on, Masdar, for example. So I think theoretically it's possible. I don't know where one might particularly select that location, but you probably want somewhere with nice climate and a bit of a river and a port.
We might just have one last question, and because afternoon tea has arrived, so we might just have one last question before moving on, if there's one. Yes. They're up the back. They're quickly getting here. Thanks, Amanda.
Thanks. Wayne Egerton from Saab Australia. I'm interested in the optimisation of infrastructure through the use of technology, and your thoughts about the risks that we're building in through doing that. So if you look at the current electricity infrastructure as an example, where we've built interconnectors, we've connected up all of our networks, and the trade-off is that we've had to produce less generating capacity. But when it goes wrong, we have a significant problem. So what are the implications and what are the risks and the downsides of smart infrastructure in cities?
Yeah, that's a very good question, isn't it? Someone once said to me, don't ever say that's a really good question because it means you don't know the answer. And in this case, that'd be right. Look, I think a lot of it, if you look at the energy system, and you're right, what you pointed out is right. And energy arguably is the one with a much better functioning market, and yet now we're still seeing problems. So, if I think the current political and public discourse around energy is going to cause a lot of thinking and a lot of public soul searching about have we got it right. But I don't know that it's necessarily a technology issue so much as that's, to my mind, more of a market come regulatory come public policy set of questions that's led to that. I come from a state where we've actually got a pretty well distributed network, and it's arguably more resilient because we don't rely on interconnectors. flip side, it's also probably one where we'll struggle to actually integrate renewables into the baseload mix because, you know, that causes some issues. I think ultimately, I think anything to do with the integration of technology needs to be done through a really good, solid public policy decision-making lens. You know, you rush anything, you're always going to have problems with it later on down the track. My gut feeling is that there's a lot of work to be done in the public policy side of integrating technology into our infrastructure systems. There are lots of examples where things that probably should have worked very easily have not worked because either the regulatory system wasn't set up to deal with it or the market chose for whatever reason to not adopt it. I think you've raised a sort of a really complicated set of public policy market issues. And I don't know that there's any single answer, but I'd hate to think that we stop trying because that might fail. And I'd really hate to think that sort of some of the market gains that we've seen in energy get unwound because of a current set of circumstances in a couple of the southern states. But this is I mean, Sarah put the slide up before around wicked problems. I reckon you've touched on a wicked problem as the last question of the morning, or the afternoon. So thanks for that.
Thank you, Wayne. And would you all join me in thanking our four speakers this afternoon's session? So C.T. Ling, Darren Crombie, Sarah Stacey, and Philip Leong. So thank you very much.
Ladies and gentlemen, if I could invite you to take your places again, and we'll get on with the next workshop activity. Just while you're taking your seats, dinner this evening is just next door at the Yachts Cafe. That's YOTS. You'll see it's the cafe just there. It'll magically transform into our dinner location tonight. So not too far from here at all for dinner. Thanks.
All right, folks, we're hopefully you're suitably caffeinated, sugar infused, etc. So what we're going to go on with is a couple of short, sharp workshops just to round off the day, and we're going to build on the first workshop and the priorities that you've identified. And it's worth probably just I suppose for everybody's awareness, I'll just show you kind of, so what we did was a quick little summation of what everybody was discussing. And so you could, and these were your themes, your three identified priorities, I suppose, and you can see the various tables there. And it's a really kind of, pretty interesting kind of bunch of topics, and this is in that, this is more towards the kind of future end that we were targeting. So what we've done is a bit of arbitrary selection, because that's what we're allowed to do, and so the highlighted one is the one that we want your particular syndicate to kind of really kind of focus in on. Yep. And I know kind of, people will come up to me after and go, oh, JP, but I was really interested in this other one. We can talk about that afterwards, but right for the moment, this is the one that we want you to kind of focus on and drill into. And we want to actually look at it in more detail and actually do a kind of an impact assessment of what that technology or concept actually means. So we're going to use what's called a futures wheel concept to actually kind of take you through that. And so just to give you a picture, Nigel mentioned the steep V construct before in terms of a way to actually consider a problem. And so on your boards around the place, you'll see now that framework set up, and you'll see your big idea at the centre or somewhere on the page. And so we want you to have a look at that big idea and actually have a look at the first order effects of this from both from a social, from a technological, an economic, an environmental, a political, and a values perspective. Yep, and that gives us a kind of a pretty good kind of rounding of the impacts of that particular technology. So that's the first order effect, and then it doesn't take kind of rocket science to kind of go. Then we want you to just take it one step further and explore the second order effects of those, to actually really kind of get into the consequences of each of those particular themes for your big technology, for your big idea. And we're going to keep these. So this piece of work is going to stay with us and won't be rubbed out. and we're going to take it forward over the course of the next day. So that's the first task that we'd like you to kind of tackle, and see how you go on that. And then we'll have a go for about 30 minutes on that, and then I'll reconvene us all and we'll go into the last activity of the day. All right? So, using Steep V, your boards are up there. You should all there be with your big idea. Take about 30 minutes and work through those different factors in your groups. Yes. Oh, thank you very much. So, first order effects, one colour. Second order effects, another colour. Nicely done. And write small. Thank you, creative design lead, Chris. Alrighty. Thanks, folks. Onwards and upwards.
to the Emerging Disruptive Technology Assessment Symposium. EDTAS helps the Next Generation Technologies Fund and strategic planners understand the impact of emerging technologies in the defence and national security landscape for the 20-year timeframe. We'll explore the long-term implications through a multidisciplinary immersive workshop environment. DST, in partnership with the University of Technology Sydney and Noetic Group, are hosting this symposium on information, knowledge and digital disruption. Information technology continues to gain momentum, shaping and shifting the way we operate. In the next 10 to 20 years, new technologies such as the Internet of Things, big data, AI, machine learning, automation, along with virtual and augmented reality, will transform the way we live our lives. In the defence context, this rapid change presents both an opportunity and a threat. The growth of data, the fusion of technologies and the complexity it poses could disrupt society broadly and also the manner in which defence does its business. This symposium will explore these challenges with a view of identifying the key research areas and areas for future industry focus that will ultimately improve defence capability. We'll be exploring four main themes through EDTAS, which are information and knowledge technologies in the 2040, the application of these technologies for that time in a smart city, capability concepts around digital disruption, and finally, the socio-economic and ethical considerations of information and knowledge technologies. The symposium will consist of a series of presentations from leading academics, defence, government, industry, followed by a Q&A panel session, and then explored in detail through a series of workshop activities framed with immersive videos. For our YouTube viewers, we want you to be involved and be part of the discussions here at the symposium. The presentations will be streamed live and we encourage you to comment and ask questions via Twitter. Some of these questions will be put to the panel during the Q&A sessions and others may be used through the workshop activities. This will be an exciting symposium and we hope you're able to join us for the whole event. Welcome to EDTAS.
Ladies and gentlemen, we have about 10 minutes left on this particular activity. 10 minutes, thank you.
round and add to it, yeah? So kind of don't necessarily think that you could have done on this. But what we will do now for this last activity for the day is we want to take this, what you've been thinking about, and put it into the context of the megacity. So the idea with this is that we actually want to take the big idea you've been working on, but we want to put it in now an actual kind of environment. So we've just got a short video just to kind of immerse you in the future megacity, just to kind of give you some thoughts, and then I'll come back and give you some more instructions.
Good morning, Ethan. Happy election day. Hydration levels are low. Your coffee will be ready in 2 minutes. Health check complete. Ethan, how about some aerobic exercise?
Not today.
Your food supplies are low. You need to acquire food for 2 days. Would you like me to check your newsfeed?
Just the headlines.
You have 18 work tasks to do today. You will need approximately 5.5 hours to complete these tasks. You have 5 new messages, 4 personal and 1 business.
Read me the business message.
You are required to attend a meeting at the corporate hub in the Sydney megacity. Traffic is heavy and travel time is approximately 1.5 hours.
Okay, let my colleagues know my ETA.
Okay, done.
Okay, and so you'll have seen from that there's a bunch of kind of themes that we've kind of tried to introduce you to.
Good morning, Ethan.
From kind of
Happy election day.
Morning, what's a typical kind of morning routine? Moving to a place of employment, and what does that kind of look like? How do I shop? I need to acquire some groceries. How do I travel? Et cetera, et cetera. And you would have there's connectors obviously to kind of the futures we've done in terms of those different factors, and I think you can start to kind of see some parallels there. So with this one, what we want to do is we want to try to map that out. So I want to go back to kind of like the first workshop, and I want you to kind of just represent a day on the board. So literally a line, and just map it out in terms of kind of that morning, there's news, and there's food, and there's travel. Yep, and we're going to consider your big idea, and I want you to keep to your big idea that you've been working through, and what's the impact of that on those different factors that an individual goes through. And then if you just scale on the right-hand side, just to kind of graduate and give us a sense of kind of, you know, what is the impact of that. So I was going to suggest that we post-it note it, but seeing as my post-it notes were such a they've gone non-sticky or whatever, we can use you can use texts just as much. And so what you should end up with, start to kind of build again those impacts and just what they are. So just state what that impact is on an individual using your big idea. So be it kind of Internet of Things or artificial intelligence or whatever, and use those kind of those quadrants that I've suggested, just as they're a good guide, and try to kind of, you know, quantify how much of an impact it'll be. And then the last thing I'd just like you to do is then do the reverse. So you know, there's a positive impact, yeah, for this that this is going to have on the individual, but there's also potentially a negative impact as well. And I want to explore those as well. And you can flick back to your futures wheel, because on your futures wheel you'll have some of these. You'll have the societal and the values piece, and that'll have an impact on you know, on some of the actions of an individual. So that's what I want to explore. And where we'll get to at the end of this is hopefully we'll have put our arms around this big idea, and we'll have it from a broad perspective, a level of understanding, and we'll also have it from an individual. And that's where I want to get us to, so that we've tried to kind of do the so what's of this technology and the impacts of it in the future. Clear as mud, he says? Good. So we've got about half an hour, and then that's it. I'm going to let you go. So then we'll go and have dinner and all those things. So back to your groups. One last charge. Looking at it just take that video as a guide and follow that future person too. We're going to write. Yes, we're writing on the whiteboard. We're not using post-it notes. Okay? Oh, thank you. My colleagues have just reminded me that this is one for the note takers. Sorry, just one.
you.